So, should we go directly or?
No, okay.
Sir.
A very good morning to one and all present here. Good morning, everyone. A very warm welcome to all the dignitaries, respected teachers and students. A special welcome to the students who have come to participate in the various competitions of the National Technology Day 2023. I am Ms. Sahana P. Shankar, faculty from Computer Science and Engineering Department, and I feel privileged to host this National Technology Day for the year 2023. The theme for National Technology Day 2023 is School to Startups, Igniting Young Minds to Innovate. This year, we have scheduled various competitions for the school students that is happening in the D block right now to ignite the young minds. Before we begin today's program, may I request the dignitaries, Dr. M. Girish Chandra, Principal Research Scientist, TCS Bangalore, Dr. A. Sivatanu Pillai, Professor Emeritus RUAS, Dr. M.R. Jairam Sir, Honorable Chancellor, Ramaiah University of Applied Sciences and Chairman of Gokula Education Foundation, Mr. M.R. Srinivasa Murthy, CEO of Gokula Education Foundation, Professor Kuldeep Kumar Raina, Honorable Vice Chancellor of Ramaiah University of Applied Sciences, Dr. Om Prakash Kharbanda, PVC Health Sciences, and Professor Govind R. Kadambi, Pro Vice Chancellor and Dean of FET, Ramaiah University of Applied Sciences, to please grace the dais. Thank you all. The Ramaiah anthem embodies our institutional identity and encourages a greater sense of belonging within our university to demonstrate who we are and what we stand for. On this occasion, I request you all to rise for the Ramaiah anthem.
ಕಟ್ಟಿದ ಕನಸಿನ ಸಾಮ್ರಾಜ್ಯದಲ್ಲಿ ದೀಪಗಳು ಪ್ರದೀಪಗಳ ಬೆಳಗುವ ಶ್ರದ್ಧಾಸ್ಥಾನವಿದು ಜಿಗಿಯುವ ಸಂಪನ್ಮೂಲವಿದು ಗೃಹದಲ್ಲಿ
Thank you all. As they say, do not pray for an easy life, pray for the strength to endure a difficult one. As we march forward with great hopes and aspirations, let us invoke the blessings of God to be highly successful in all our ventures. At this auspicious occasion, I request Ms. Vaishnavi N. from the Department of Civil Engineering to invoke the Almighty.
महागणपतिं मनसा स्मरामि महागणपतिम् महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दितमहागणपतिम् महादेवसुता गुरुगुहनुता महाकोटि प्रकाशं शान्तं महादेवसुता गुरुगुहनुता महाकोटि प्रकाशं शान्तं महाकाव्यनाटकादिप्रियम् महाकाव्यनाटकादिप्रियं मूषिकवाहनमोदकाप्रियं महाकाव्यनाटकादिप्रियं मूषिकवाहनमोदकाप्रियं महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं
Thanks, Vaishnavi. We are thankful to our Honorable Vice Chancellor, Professor Kuldeep Kumar Raina, for his gracious presence on this special occasion in spite of his busy schedule. Professor Kuldeep Kumar Raina, well known for his scientific acumen and leadership, joined RUAS as Vice Chancellor in April 2021. Sir, thank you for joining us today. May I request you to please deliver the welcome address?
Namaskara and good morning to all, ladies and gentlemen. Our Honorable Chancellor, Dr. Amar Jairamji, the chief guest of the inaugural function today, the keynote address by Dr. M. Chandra ji, our very distinguished and owned Dr. Pillai, Professor Emeritus at Rama University of Applied Sciences and a well-known distinguished space scientist, my colleagues, Dr. Kharbanda, the Pro Vice Chancellor Health Sciences, and Dr. Kadambi, the Pro Vice Chancellor of the University, Professor Razdan, the advisor in assuring the quality of the University, Dr. Megarao, the Dean of Academic Affairs, all deans, directors, members of the faculty, beloved students, guests, ladies and gentlemen, Mr. Murli from the Era Foundation. This time we have also invited some school children who are also attending this, both in the real mode as well as in the virtual mode. Wishing you all the best for the day and a wonderful day indeed. At the outset, I thank our Honorable Chancellor. It is his vision. Soon after having the Board of Governors meeting, we had a brief discussion that we should launch one of the memorable events in memory of our founder chairman, Dr. M.S. Ramaiah, something novel, something new. Thank you, Professor Pillai. You were also present and witness to that occasion when we discussed that how we are going to steer and motivate our young students in taking up some challenging opportunity. And what came in our mind was building, developing, crafting, and creating an idea of launching Ramaya Sat. And today is the day when, under the auspicious hands of our beloved chairman and the chancellor, Dr. M.R. Jairam, and in the gracious presence of all distinguished speakers, guests today, we are going to launch it. Let us have a great applause for the day. What would have been the best occasion than celebrating on the eve of the National Technology Day? India takes its pride in expressing and showcasing the best of the capabilities that we have evolved over the years in developing our own indigenous technology. In space, I think India needs no introduction. Eminent scientists Vikram Sarabhai, Satish Dhawanji, APJ Kalam, and we have our own great people who have contributed from time to time, Professor U.R. Rao. All these are the giants who have put India into an orbit where today world is glaring at us that it is India, and in space technology we have made our mark felt. We thought at times that how we are going to give this best thought process in the minds of our young budding students. So over the last couple of months, a collaboration was established between Ramaya University of Applied Sciences and Ramaya University of Technology. I am happy to share with you all that around 150 students took active part in creating, crafting, innovating, and developing the Ramaya satellite today. 75 students from RUAS across the disciplines and 75 students from Ramaya University of Technology across the disciplines. So this cross-disciplinary, transdisciplinary interaction has helped us to see the day which we are going to inaugurate within the next half an hour or so. With these words, I have a great pleasure in informing you about all that. Let us present a token of love to our chief guest at the inaugural function, Dr. Girish Chandra. So, with these words, I once again extend a very, very hearty welcome to you. I am sure this is going to be a thrilling experience to each one of us. Let us pray and wish great success to the launching of Ramaya satellite on the orbit. It has its own special features, which we will come to know very soon. It will have the environmental monitoring system. It will help the farmers in precasting that what are kinds of the soils. It will also help us in so many other activities, and which is till we inaugurate it confidential, and our team members will tell you what are going to be the ramifications, the advantages of this Ramaya satellite. Thank you very much. Jai Hind, Jai Karnataka.
Thank you, sir. On this auspicious occasion, I request the dignitaries to please join for lighting the lamp to spread the divine grace.
Namaste.
Thank you all. I now invite Dr. Rinki Sharma, Head of the Department of Computer Science and Engineering, to hand over saplings as a small token of appreciation to our dignitaries, Dr. A.S. Pillai, Professor Emeritus, RUAS, Dr. M.R. Jairam Sir, Chancellor, RUAS, Dr. Kuldeep Kumar Raina, Vice Chancellor, RUAS. I now invite Dr. Naina Patil, Head of the Department of Civil Engineering, to hand over the saplings to Dr. Om Prakash Kharbanda, PVC Health Sciences, Dr. Vedha Ram, Dean Academic Affairs, and Dr. Sumit Soman, Senior Data Scientist, Ericsson. I now invite Dr. Malati to hand over the saplings to Dr. Ashish Kushu, Chief Technology Officer, L&T Services, Bangalore, Shri M.R. Srinivasamurthy Sir, CEO, Gokula Education Foundation, and Professor Razdan. And Dr. Girish M. Chandra Sir, our keynote speaker for the day. Thank you all. I now invite Dr. Govindar Kadambi Sir, PDC and Dean FED, to introduce our esteemed keynote speaker, Dr. M. Girish Chandra.
Respected dignitaries on the dais and off the dais, delegates, dear colleagues and students. It gives me great pleasure to introduce the chief guest of today's function, Dr. Girish Chandra. Of course, he is our mentor, he is our friend, and he has been a long associate of earlier the School of Advanced Studies and now the University of Applied Sciences. Dr. Girish Chandra received a BE degree in electronics from the University Vishweshwara College of Engineering, UVC, Bangalore. He obtained his M.Tech in Communication Systems and High Frequency Technology from IIT Madras, and he graduated with a degree of a PhD and subsequently a DIC as a Commonwealth Scholar in Digital Communication from Imperial College, London. Presently, he is a Principal Research Scientist with the TCS Research India. He has over 100 publications in journal conferences with the co-authors, and he has been granted more than 25 patents, and he has filed more than 50 patents with other co-inventors. And his current research focus is on quantum technology, particularly quantum algorithms for NASQ and beyond, and quantum sensing and quantum communication. Other interests are in the broad areas of signal processing, communication, machine learning, including the intersection, graph signal processing, compressive sensing, sparse signal processing, source separation, error control coding, channel equalization, geolocation, cognitive radio and networks, cross-layer design, adaptive and multimedia signal processing and machine learning for large big data. Again, I would like to impress upon all of us that something we have to really learn from Dr. Girish Chandra. Over the last 5 years, actually, there are two topics which have emerged really prominently in the area of communication. Somewhere in the year 2018-19, sparse communication was in progress, and recently we have been hearing of quantum information or quantum computing. To his credit, actually, in the year 2018 and 19, despite all his leadership responsibilities, actually, he underwent crash course and tutorials in compressive sensing, and he has done wonderful work for the TCS in that area. Again, quantum computing and information is an emerging technology. Again, that in a very, very short span. He had a jump start with his aptitude of undergoing crash courses, and he has contributed very significantly in that area. With these brief remarks, it is my great pleasure to welcome Dr. Chandra to deliver the keynote address. Thanks.
You will have a presentation. We come.
Let us give you some kind of a warm up on TCS research. Just keep seeing us. Okay, hope you could just see the various activities which are happening in TCS research. And of course, you must have also noticed rather the importance of cross-disciplinary approach in the present day inventions and research. It's extremely important that I'm going to re-advocate and nail down again and again during the course of this small presentation actually what I have. And fortunately, I think when I just entered this hall, I could really just see very bright young faces. And also I think when I was just trying to finalize the topic, I was in a confusion whether to go for something which is well matured and also where I am much more comfortable. But I decided to go with the quantum computing and quantum information processing, particularly in this talk, which is going to be extremely important for India. I think for various reasons that I will just again pinpoint. And apart from that, again I will just advocate for the young minds. You should know various basic sciences, mathematics and engineering to make this work. And of course, there was a sort of statement I could see in the letter from school to basically the incubation of the industry, basically startups. Basically, you are just actually going towards the startups, and this is one area where we can really just do wonders from India. Why I will just reiterate how we can just do with some kind of simplistic sort of application of mind. Of course, you have to be a little bit clever, but once that is done, there is plenty of scope to just carry out these kinds of startups, and including the government funding, which is going to be available. So with this, actually, let us just move. And of course, these are the accomplishments we just reached. So I just started this area more rigorously from last 3 years. And as Professor Kadambi sir was mentioning, so many sort of lectures, videos, and other things actually helped me during the COVID time to just grasp this beautiful area and then create some kind of a mark in this frontier. So, and most of the time, I worked with large youngsters. Many interns, in fact, most of them, even after completing their tenures, they are working actually just without stipend to just contributing to this beautiful area, because the area is so exciting. Many times we feel actually we work all the 7 days, and sometimes we can't even sleep because the excitement is so much, and the area is also really, really fantastic. Very, very beautiful area, and particularly for engineers from any background, they can just venture into this and then really just make a sort of contribution. I think I'll just let me get this point. Something has to be enabled. It's okay, you can manage. So let me just reiterate few points. I think even though I have prepared a lot of slides, I don't just even plan to just cover everything, because I think I have a short duration of time. So somebody has to alert the time, actually just alert actually to just suppose stop at junction, so that I will put it to a logical conclusion. So and of course, the quantum revolution is something just very old. Of course, it started from 1900 to 1950, and we had transistors, lasers, atomic clocks, global positioning systems, and so on. And all these actually they were just using quantum mechanics basically to just fine tune or to get into their operational code. But this is very extremely important to just know that, for example, when you just say frequency of the laser, threshold voltage of the transistor, those are all derived from quantum mechanics. But these devices actually operationally just are mainly classical. What I'm trying to say is, even though when we just try to characterize them inherently, we need quantum mechanics, their operations are largely classical. When I just say quantum, there are two words we always just say. Classical word, classical computers, classical processing, and also there is new quantum paradigm. Now the second revolution is underway, and this is for the 21st century. And if you just see, we are seeing new technologies basically. One is in the quantum communication, quantum computation, quantum sensing and metrology. So I think you keep seeing these terms, QCOM, and QSense. And of course, if you have just gone through a few sentences, when people just, the inventors of quantum mechanics, they didn't foresee actually any of the applications. For example, internet, they never just foresaw. Similarly, we are just seeing some of the things which are going to just emerge, but still we cannot foresee all its consequences, the quantum technology. So in that way, I think only the imagination and also future prospects are extremely bright. So these are the things you have to just note. And then let us just move to the next slide. So, and one more thing, why again, I think I did not even stress the importance of the sort of just market the term quantum technologies, because now everybody is aware of that, because we know there are what are called as multi-qubit quantum computers available on the cloud. I think those who are not fully comfortable with qubit, when you say qubit, it is a quantum version of the bit. Classical digital computers use bits, and we have a special entities called as quantum bits. So we have quantum bits in the quantum computers, and these machines are now available freely, and of course small machines are available freely actually to the general public through cloud. In that way, I think quantum computing from last few years has created an awareness in quantum technologies, and most of the institutions are aware. And of course, IBM conducts Qiskit Global Summer School, and most of the set of entrants, that's free actually, are from India. many youngsters actually just participate and learn this beautiful technology. So, apart from computing, as I was mentioning, this communication and the metallurgy are also just undergoing extensive kind of investigation and intensive research activities. Why these are important? These can bring new and or enhanced capabilities. That means sometimes they bring new capabilities that are not possible with the present devices or the systems or the technologies, and also they may enhance the capabilities of the existing systems. So this is very important. And of course, we are now actually just in the very exciting phase of quantum technologies. And why it is? Because I was mentioning about 1900s. Because you have seen last few decades, what has happened was we have quantum delicate objects. Okay, I'll come to that a little bit later if time permits. These objects were only just used to be seen. That means they used to be observed. But we didn't have the engineering or the technology to manipulate them individually. Okay, that's what we mastered from last few decades. Once you just come to, for example, a single photon is a quantum entity, and a very an electron is a quantum entity. Then how do we just manipulate and control them to just harness their power? That has just happened through meticulous engineering and science from last few decades, and we are in the right exciting phase, particularly for youngsters to take off now. And one more thing, now I said about computers available, quantum computers, but apart from that, many SDKs are available, software development kits are available. You may not actually just go and build some system, but rather you can simulate and see at a small scale with the small examples how these things actually just work. Okay, this is actually another thing which we have just keep in mind in this exciting phase. That means basically the youngsters can build and run and then understand and also just invent. That's the beauty of this thing. That's why I think I will just show in just last 3 years, actually just with some interns, we have produced 25 plus papers in our top conferences. Because the area is so far, sort of niche. Any small observation, new observations you make will go as into research. Of course, there was a sort of saying in the quantum mechanics era in 1900s, every PhD thesis was eligible for Nobel Prize at that time. Because things were new. So all the things actually contributed to the field. So in that way, I think that's why I can't just overstress the importance of this. And also even small hardwares are available, like quantum random number generator, and small portable NV center, nitrogen vacancy center based quantum computers which operate in room temperature. So these are the things actually which we are seeing in this exciting phase. And all countries are making huge investments. We have a national quantum mission. I think in May 23rd or 24th, I'm not recollecting the exact date. They announced the release of the funds basically for various thrust areas in quantum mission. And we also locally we have a plan for quantum research parking from the government of Karnataka, and that would be just even corroborated through IAS. So we are also part of that initial discussion. So in that way, I think plenty of things are happening, and both industry, academia will get benefit once we just do some fantastic sort of impact with some initial research. And this is the final, the last line of this slide actually is basically the website address of the government funding. So let me just go to technical details. When you say quantum computing, two things have to be just kept in mind. One is information is physical. We can't just simply just say, okay, it is detached and then think in abstract terms. That was happening. That was also okay. But now we have to just say information is physical. And once you just say what is that physical system, it's very simple. If you just go back to your school days, then that's why I just when I teach even youngsters, I think they will just really just fascinated by how simple things are. But you have to just put a different perspective. That's what I'm just going to lay down. When you say physical, the physical system has got a physical state, physical entity has got a physical state. So therefore, quantum information is stored in the physical states of a quantum system. So these quantum systems may be atoms, molecules, ions, photons, superconducting circuit. That means we can even just build a macroscopic circuits to behave as atoms. That's the beauty of engineering. And there are even mechanical oscillators are advocated to just behave like quantum objects. So the first thing is information is physical. Whenever you think of information, think of physics basically. Just go to the next slide. And then the information processing is also physical. We have to just take a different view now actually. So for example, again actually just I will not go into the details. When you say information processing is physical, and also just information is physical, there are various ways the information can be just even glued into that physical entity. For example, there are some 4 important models that we have just at least note on. One is the circuit model of qubits and gates. That means there are qubit based models, and then there are what are called as adiabatic quantum computing. Don't worry about these terminologies. You can do homework later. Okay. So, and then one-way measurement based quantum computing, the continuous variable quantum computing. So I was mentioning about the observation of a quantum entity. When you observe, it can just throw out either the discrete values or the continuous values. That's how we have the circuit model, discrete model based, that are basically based on qubits, and also continuous variable quantum computing. Just you can just remember for the time being. So in that way, what I'm trying to say is, you have either the continuous variable systems, which we just call as Q modes, or the qubits actually based circuit models, and even adiabatic computing uses qubits. These things actually just are going to be governed by some kind of mechanism called as Hamiltonian. That means that when you say quantum, there is a quantum system, that means maybe number of qubits that you all are aware, because we can't just work with only one qubit, but rather a register of bits we work. Similarly, we have a register of n qubits. Once you have the n qubits, we have an n system, and that is going to be just governed by something, because now we have to think everything in terms of physical aspects. Okay, so then there is a governing physical aspect that is called as Hamiltonian. Okay, don't worry about the details, that I can just take a tutorial later. So this Hamiltonian, if you just somehow put it into the system, that will just make this state to evolve. Okay, so what I said, okay, the information actually is carried in the states of a physical system. That is how it is coded. Now, when you say computing or information processing, we have to transform that state. How do we do that? There is an Hamiltonian, and actually that actually just make that state to just evolve according to the way we design the algorithm. Okay, this is what you have just do it. And one more very useful thing to just remember is, these are all happening in the quantum world. We have to bring the values to our real classical world. For that we make measurements. Once we make measurements, we just not get the values right away. That means basically what we get is a sample of values. So when you say state, for example, I just started with a state and moved to another state, and that state, when you measure, can give some output. And when you just, for example, again you prepare and run, that means you just conduct the experiment, then you will get a different output. That means the output is inherently probabilistic. Okay, this is not because of our limitation of understanding the system. This is also extremely important. The quantum phenomenon is inherently random. So you have to just get, that means basically when you just put a state, you are going to get a probability distribution, and from those, if you keep measuring, you will get the samples. And from those samples, you have to extract the information or the answer you are looking for. Therefore, it is opening up a new kind of paradigm. So this is extremely important. You have to think differently. Once you do that, I think we can do wonders. And therefore, if you just say, I'm just seeing developing an algorithm, in the gate model base, we see a circuit. I think, for example, those who are already comfortable from digital logic, you have AND gate, NOR gate, and those circuits are put. Here also there would be some kind of circuitry. And for conducting a particular sort of an operation, you will see a completely awkward circuitry in place, which is emerging from the quantum behavior of the whole system. So what I'm trying to say is, many times you have to just completely think differently, and they may look alien, but actually that's the way to just design it. So this is extremely important. Just don't try to just move from whatever is known and then just extend. That is not possible. You have to think differently. That is another important point which we have to just keep in mind. Probabilistic, and we are just trying the surface basically. And of course, you can just go to the next slide. And now, this is extremely important. I will just come to why it's important to just design algorithms basically. I think I need not stress the importance of algorithms for the students and the teachers here. So, I was mentioning we get a state, quantum state, and then that quantum state actually just throws out different answers when you just re-prepare and run. So we have to just getting some probability distribution, and that probability distribution, when you just sample, most of the time you should get the right answer, because otherwise what will happen is it will actually just throw some random numbers, which is not at all useful. So the main important thing in the quantum algorithm is design these kinds of gate mechanisms. Here I'm just showing only the single bit and the 2-bit gates, because there is a theorem to just show that by using 1 and 2-bit gates only, we can approximate any kind of quantum operation in the closed system. So I'm just doing some technicalities. So when that is the case, that's why you are saying single qubit operations, coupled qubit operations. And once these things are appropriately put, this is our algorithm, then what happens is some of the coefficients of the state would be very close to 1 and rest of them would be 0. So those who are close to 1, those are the answers which will always emerge. That means you have to design your sort of algorithm in such a way that the right answer you are looking for should emerge with higher probability. That means you will just sample only once or twice and get actually the requisite answer. Okay. So this is actually the way to just somehow look into. And when I said, I already just somehow just nailed down the randomness, and that is also inherent in basically the basic characteristic of qubit itself. When you say qubit, basically what it says is, when you measure, you will get two distinguishable states. Either we can call them as 0 and 1. But only thing is, in the quantum bit, we have a linear combination of basically this 0 and 1. That's what actually I'm putting in Dirac's notation basically. So this can be in the superposition. It can be a linear combination of a 0 and 1. That's the quantum state. Therefore, it is more kind of powerful. This is the quantum superposition. And also, if you just see this, it has got aspects of both 0 and 1, both 0 and 1, and therefore, naturally, quantum actually just comes with inherent uncertainty. Okay, it's the future. And now let's go to the next slide. Then, apart from that, I was mentioning about having multiple qubits, basically, because we want to operate on a register. And there is one more very beautiful property that is a very kind of a special correlation in the quantum systems. So if you are the qubits are, let us say, are entangled, then operating on one qubit actually will just have an effect on other qubits. This is extremely important, the entanglement property, and this is actually just kind of one of the resources which you have to exploit in quantum computing, communication, and also quantum sensing. So I think let us just move to the next slide. Somebody has to elect the time, basically how much time. Yeah. Now, I was mentioning about some quantum computers are already available in the cloud. They are basically the small computers, basically, and they are noisy because in the present systems we have, there are various sources of error. I think this you can just see basically decoherence, gate fidelity, readout error, and the qubit. These are kind of limitations which we just have with the present computers. And the computers we have, since they are noisy, they are now presently just termed as, of course, right from last few years, they are termed as noisy intermediate scale quantum computing. Now we have 100 plus qubits, and we have not fully connected qubits, because remember, when we want to connect, when we want to entangle, we need the full connectivity in the ideal case. But we don't have the full ideal connectivity, so we have to operate with the limited connectivity. So therefore, these things are all limitations. We have the noise, and also the number of qubits are not too many. And now, one more thing, if you just so let me just continue. So one more thing, actually, what is happening is these qubits are basically the quantum states we just started with. They will just decay with time. That's called as decoherence, and we lose the quantum behavior. Then actually it's no use actually, because we are trying to just exploit the benefit of quantum nature of the system. But it is not actually just going to happen. Therefore, we have to, within a short span of time, which is called as coherence time, we have to just carry out the requisite operations. That means what is happening, we go to the next slide. So what is happening is, we have only fewer number of qubits. If you just see this kind of whatever each of the lines has kind of a qubit star, which is coming from a qubit, we can go up to certain depth only. Okay, we can only carry out few operations. Otherwise, I think because of the decoherence which I just mentioned in our present era, we will end up in errors and lose the quantum behavior. Therefore, what we can do with one small number of qubits and a kind of limited depth circuit, that's also that is very, very important. So this is why newer and newer algorithms can be just worked out within this regime. And apart from that, if you presume, okay, there would be a very big computers with all sorts of idealness built into it, those are called as fault tolerant computers, then you can still design algorithms theoretically. Therefore, we have both options, and in the present NISC era, that's why whatever the small things you do can just bring out some newer algorithms. Okay, so but the things are not that easy, but just feel that it is easy, then only you can just move. Okay, just to go to the next slide. So I was mentioning about this gate and other things. Basically, that's actually one model. There is another model called as quantum annealer. This is also very important because you have to just remember this. There is a sort of company called Keynote, which actually provides this quantum annealers. They are very good in solving optimization problems, particularly what are called as our combinatorial optimization problems. So, and of course, those who are from engineering or even other backgrounds, they know these are very hard problems. I will just come to the complexity a little later. But these hard problems actually map into many set of real world problems. Okay? Therefore, we need very good what are called as Kubo solvers, that is quadratic unconstrained binary optimization problems. That means when you see a combinatorial optimization problem, what we are looking for is a string of ones and zeros. Whether, for example, let us say we are just considering a portfolio optimization problem. We have a set of portfolios. Wherever I get one, I will just select that asset as the portfolio into the basket of my portfolio. Just very simple example. These kinds of problems, whether it's traveling salesman problem, max cut problem, max cut is basically dividing into two groups. All those things actually just map down into this Kubo problem. So there are efficient Kubo solvers which are just required, and this quantum annealers can just play a wonderful role in that. Let me again just put a physics view for this. It's very interesting. What we have to do is we have to design. We have to just get an appropriate number of qubits and map the cost function into what is called as Hamiltonian, because that's what I was mentioning. The entire system is governed by the Hamiltonian. If you just map your cost function to the Hamiltonian and start with another Hamiltonian for whatever the reasons for the timing, I just leave it aside, and then you evolve the system basically to reach that Hamiltonian. Then once that is there, all the physical systems try to go to the lowest energy state. That's the nature. That lowest energy state actually will you, if you leave that out, you will get the answer basically. You are sampling again. So that's what actually now I think I will just try to lead down to sort of points which I just scattered earlier. So that's how you have to think. You have to design an Hamiltonian, and then the lactible qubits get governed by that Hamiltonian in a particular way, and then it settles for the lower energy system, so lowest energy state. That state is actually the solution you have to think about. Naturally, it solves optimization problems and large scale optimization problems, and that are not possible even with the present resolution scale. So already I just mentioned about this optimization. Let's go to the next slide. I think now this is what actually just why actually DGS is doing all these things. I spoke about all these things. So 5 minutes, okay, no problem. So then I think I just complete with this. So we have to bring out quantum enhanced algorithms in different domains. Okay, that's very important. We have various domains actually to address in industries. Then we have to get it. Already I was mentioning about noise intermediate gate quantum hardware is available. We have to get maximum advantage out of those. And then these are some of the sort of things. Why these new algorithms are important? Because this is actually few sentences we repeatedly see in the industry and also all other literature. New algorithms make the biggest computational leaps, and competitive advantage comes from in-house algorithms and techniques. Therefore, I encourage even students and faculty to just somehow develop new algorithms and patent them. They can really just create value. Okay, so I mentioned about quantum enhanced optimization, and there are similarly quantum machine learning and quantum sampling and stochastic modeling are also important, because these are the things which we are addressing in our research group. And also there is an extensive activity in quantum chemistry, because remember, when you say chemistry or molecular problems, they are inherently quantum mechanical. In order to just even just mimic them, how they behave, you have to use quantum computers. So therefore, they are going to just play a significant role in quantum chemistry, like in material design and also drug design and all those things. Okay? And then quantum sensing also we have just started looking into. So this is, and also as I was mentioning, we are not just restricted to one kind of a model, because IBM, Rigetti, all those people actually just provide gate-based computing, but we are just open to both the gate model and D-wave annealer. In fact, we are combining both of them in one of our newer algorithm paper actually. So, and why these are important actually for us? Again, there is we can move from initial exploration to proof of concepts, and we have various use cases in banking, finance, life sciences, medical, and there are many complex problems just exist in all this. Go to the next slide. So this I will just touch one the next slide and then close it. I was just mentioning about not quantum algorithm, but something like quantum enhanced machine learning, quantum enhanced by optimization and so on. Why it is so? Why? Because in the present Niskira, the architecture which is actually making kind of sense or which is working is what are called as variational circuits. Okay, that means we have a classical computer and a quantum computer working together in tandem, judiciously just put into action to get the requisite solution. And this is not only the case for the time being, but even if you just go further, what will happen is there will be a significant portion of quantum computing in future once they are available, but also classical computing. So that means they have to work together and we have to judiciously partition the task basically. That is also not straightforward. How do we just partition the task to quantum and classical to get the cutting-edge solution which we are looking for in any domain for that matter, maybe banking, finance, etc. So this is actually just very important. Therefore, we are just seeing the term like quantum processing unit, similar to GPU and all those things. This QPU is also just coming into the scenario. This is important thing to just know. Go to the next slide. So this I think you can just come. Go to the next slide. So just the previous slide. Previous. Yeah. So I'll just touch upon one quantum machine learning stuff. I think everybody is aware. I think even there is a data scientist here. I think he will just speak later. I think it has just penetrated into many of our endeavors in life. It has just the machine learning aspects, the artificial intelligence. So one thing actually just we tried was, of course, we just worked it for a BMW quantum challenge, and we ended up in top 3 in the world after this term. So you just see, I think when you say image segmentation, what we do, we have to just first get the background out. Okay, if you are just looking for some region of interest, then we have to just bring that region actually just appropriately quickly when we just keep processing. So this is what is happening with the quantum enhanced one. So compared to the classical one, so then we could just get the background subtracted out. Therefore, some benefit will just emerge when you appropriately use quantum. Again, it's a quantum classical pipeline, but there is a benefit which we can just keep. Just go to further. No problem. So I think just okay. Let me just speak and then conclude. So recently, I was mentioning about classical quantum. I also mentioned about quantum annealers like gate model, etc. Recently, we have just also proposed how we can judiciously decompose a large problem because we have small computers now only. How do we just decompose the problem? And again, in a systematic manner, not in an ad hoc fashion. Everything has to be just done with science. It is not actually just say, okay, do something in trial and error. That's not actually. That's why I just keep telling to the youngsters also. Theory gives you a good roadmap. You have to be extremely good theoreticians also. So then you can just say how we can decompose so that we can use annealers, gate model, and classical computers also together to solve a bigger problem. That's going to be the case. So I had slides about quantum key distribution, quantum sensing, and also basically quantum communication. But these things actually we don't have time to cover. So we can just stop at this. And if you just see various algorithms which you have seen or just we have worked out, you can go to my Google Scholar page and see how diverse problems can be attacked through this quantum enhanced algorithms. Right from NDPC decoding to even topological data analysis, even to portfolio optimization I was mentioning, and even how quantum sensors can be just somehow designed appropriately using quantum machine learning concepts. That's also just becoming very important. So, for example, when you say quantum sensing, let me just tell this. Quantum sensing is about, we have a probe, and there's an environment which interacts with that probe, and this probe picks up the value, the parameter, and then you have to carry out the measurements in the quantum world, basically to bring out the parameter value. And quantum will provide much more better precision and sensitivity in codes, because there are rigorous definitions. Because whatever is not possible in classical, that can be done through quantum. And this probe design and the measurement design can be parameterized and can be seen as a machine learning topic. That's how I think people are thinking. We just see every day, I think if we just see archive quantum physics, every day so many things are just coming out from youngsters and also from the faculty. I think only sky is the limit. It's a beautiful and fantastic area. So, and now I was mentioning about quantum chemistry, there's also quantum biology, learning about chemistry, biology, maths, engineering, physics thoroughly. And also the coding is very much essential. Nowadays everything is to be just shown, not like gone on my area where I was showing only the PPTs. So that's not good enough now. So you have to be just completely hands-on and then provide all the space to a kind of working kind of a situation. Drive all the other things to working kind of situation. With this, I hope I think I just try to convey and motivate you for this. And there are a couple of videos of mine, including together with my colleague, are available on YouTube. Those you can just go through for more technical details. And apart from that, I think I just today's conclusion at this moment in the interest of time. Hope it was useful.
Thank you, sir, for sharing your knowledge with all of us today. I now invite Dr. M. Sivapragasham, HOD of the Department of Automotive and Aerospace Engineering, to introduce our guest of honor, Dr. A. S. Pillai.
Good morning, everyone. Dr. A. Shivadana Pillai graduated in electrical engineering from Madras University, underwent management program at Harvard Business School, and obtained PhD from Pune University and DSc from Tumkur University. Dr. Pillai's 4 decades of experience in ISRO and DRDO under the great visionary leaders Dr. Vikram Sarabhai, Professor Satish Dhawan, and Dr. APJ Abdul Kalam made him a technology leader in the field of launch vehicles and guided missiles. His contribution to the successful development of SLV-3 as a core member and evolution of PSLV configuration for ISRO have been remarkable. As the founder, CEO and MD of the joint venture BrahMos, Dr. Pillai is regarded as the father of BrahMos, which has become a role model for establishing joint ventures between countries. Well known as a defense technologist in the world, Dr. Pillai has been recognized by many prestigious engineering and management institutions with fellowships. Dr. Pillai is a recipient of various prestigious awards, including Technology Leadership Award, Dr. Vikram Sarabhai Research Award, Organization for Industrial, Spiritual and Cultural Advancement International Award from Japan, Raja Rammohan Puraskar, Lokmanya Tilak Award, Lal Bahadur Shastri Award, Performance Excellence Award from Institution of Industrial Engineering, and most importantly, Padma Shri and Padma Bhushan from the Government of India. He has also been awarded the Order of Friendship, the highest civilian award being awarded to citizens, foreign citizens by the Government of Russia. Sir, we are indeed honored to have you here address our students and faculty members.
After listening to the contributions that Dr. Shivadana Pillai has made in the advancement of science, technology, society, humanity at large, we have great pleasure at Ramaiah University of Applied Sciences in releasing the book which he has published. I request our Honorable Chancellor, Dr. A.M.R. Jairam, to do the honors, please.
Very interesting title. Appropriate moment for this book.
So we have great honor. So thank you very much for
Thank you, sir.
releasing the book.
Just tell them.
Friends, it is Introduction to Rocket Science and Space Exploration. I have already asked my librarian to place orders for the books which will be available in the library. I think this is from a man who is in front of you, who has contributed immensely to the Indian science. And I had a great privilege of working with Dr. Pillai for the last over 1 decade. In my previous organization, he is the member of the Board of Governors. He was also an expert in my selection as a distinguished professor at some point of time. Thank you very much, sir. And Professor Pillai will say about briefly about the book. Sir, I request you. Yes, briefly.
Good morning to all of you. Most respected Chancellor, Dr. Jairam, Dr. Sridhar Murthy, Vice Chancellor, Dr. Rama, and all the distinguished people, deans, directors, heads of the departments, students, school students. It's my great pleasure to be here on this day. You know why we are celebrating Technology Day, you know? So we are, if you look at India today, it's a different country. In geopolitics, a country which is very strong can only advocate peace. What do you mean by strong? Economic prosperity, military strength, human resource, good human resource, and a democracy. All these things are coming together to only one country in the world, that is India. That is why we are celebrating the Technology Day, to see that we grow further. We should grow in the GDP rates. 6 point something is not good. We have reached 10. That sustained way we should reach. And our poverty should go down near to zero. Then only we will be saying it's a developed country. So there was a great vision of developed India in many areas. If you look at India today, agriculture, we are producing 300 million tons of grains. We have become second in the world in rice production and wheat production. And we are now imparting precision agriculture using space technology to see that we increase the production to 400 million tons, even though area has been reduced to 100. This is a very important thing, particularly for Karnataka. We are going to go in a big way for precision agriculture. Yesterday I was talking to them. See, the agriculture, implementing a precision agriculture, first country to do was Israel. We can learn a lot of things from Israel. A desert country today is green country. You know, the production is so high. If they can do it, why we can't do it? We have got everything with us. Human resource we have here, we have got technology with us, best brains of the world we have got. Our brains are used by others. We should use our brains for our own country. That is what is needed. So that is why there are schemes, our Chancellor has introduced some schemes of training the people to see that the core technology remain with our nation. Now, the startups. If you see, there's a startup in Bangalore called Satsure. They are doing precision agriculture in Andhra Pradesh, not in Karnataka. You know, we have brain, but we don't know how to tap the brain for our own place. And they have done extremely well. I know Satsure, it's a very successful program of implementing the precision agriculture in an area of 10 acres. The production has been tripled. They have made it, and with less manpower. So what your precision farming means, satellite pictures are used for soil analysis. You can make the soil to the crop, whatever you want to put it. Seed selection you can do. You can also see the growth of the plant, growth of the the paddy field and other thing, and then we use robotic for for cropping and other things. You can do that with one mobile phone. A farmer without people, he can manage 10 acres. This is the lead. This is what we are leading to, and we are wasting water. Actually, we are saying water is not there, but we are wasting water. Too much of water is used by farmers for the paddy cultivation. It is not required. So if you can control the water availability to the field, then you will be doing better job. Milk, if you take milk, we are the largest producer of milk in the world today. To take now technology, power. Mainly we need green power. So renewable sources are being deployed. Solar, we are almost reaching 100,000 megawatts. Almost we have reached that. And wind we are doing very well. And the nuclear, we are going for 12 more reactors to make it 22,000 megawatts. So all these areas we are approaching. Now government has announced one important thing, hydrogen mission. Hydrogen, they have announced 19,422 crores for hydrogen mission. This is going to be the next area of our energy. Hydrogen energy is going to be the best energy. That too, we want green hydrogen energy. That is going to be there. Then further, if you want to make better energy, I can give a suggestion that the helium-3, which is available on the moon. Plenty of helium-3, millions of tons are available on the moon. We can definitely bring and then make that use it as a fusion energy. This is not imagination. We have all the technologies, and technology has been proved how helium-3 we can do fusion energy to make it further for producing 100 times better than uranium without safety problems. Because it is the helium-3 is not radioactive, so you can do better. This is the future. So many things are possible. You can put a solar power satellite. All 24 hours that satellite will be giving power to you. Otherwise, we have to wait for the sun to be available, So solar power satellite is going to happen. So with the space going up, you can also think of many new things. In computing, supercomputers refused to us, but we are doing our Agni program because of the MTCR, Missile Technology Control Regime. Even though Dr. Kalam went all the way to Washington to request for a Cray computer, which was refused to us, we developed our own computer, Param. We developed our own computer, the Base Plus, 20 times faster than the Cray computer, which was refused. Our young people did that. 14 young people did that. That's why the Agni program, we could do it faster. So like that, now we are entering into quantum computing in a big way. Quantum computing is a mission now. Computing is a mission. And cyber physical systems has been announced as a mission. And all the IITs, 20 IITs have been chosen for carrying out cyber physical systems. There are 2 startups. And each IIT should produce 50 startups. That's the goal they have given. And these IITs are not alone. They can join with other academic institutions. We should join with them. We can do a lot of things. So the startups are being given a lot of importance in the country. Each startup, they have allotted 50 lakhs. You see that how much the help is being given from the government side. But we must use it. Proposal should come. If any one of you want a startup to be done in any area of cyber physical systems or sensors, please come to me. I will give you 50 lakhs. I have the review member to approve these startups for IIT Madras. I can do that. So like that, we have got very big schemes are coming up to make us to technologically we should grow up. That's the whole idea is that. Why you should know, history has proven that those who dare to imagine the impossible are the ones who break the human limitations. In every field of human endeavor, whether science or technology or arts or sports, anything, the names of the people who imagined the impossible and achieved are engraved in our history. So you must develop creative thinking to, all of you, particularly school children, and you must be remembered for your life. That's what you must make history. The history book is there, no? The history book you should find a page. That is what is required from all of you. That is the mission for Technology Day. Thank you very much.
It is our privilege to have you as our guest of honor, sir. Thank you very much. I now invite Dr. Govindar Kadambi to give a brief introduction about the Ramaya Sat Ground Control Station.
Distinguished dignitaries and delegates, with the approval of our Chancellor, there has been a slight change in the order of the events because we are likely to get the signal from satellite to NOAA 15 between 11:30 and 11:41, and we want all of us to really see the what we call the passage of the satellite so that we can really sense now what the ground station can do actually. In the light of it, now immediately after this event, please proceed to the room number D501, where our Chancellor and Dr. Pillai will formally inaugurate the ground control station of Ramayasat. Just because it is something to do with the satellite, I think it is our duty to really remember some of the most actual notable quotes from the fathers of our satellite program. I take this opportunity to just tell a few quotes from Dr. Vikram Sarabhai and also paraphrase a quote from Professor Satish Dhawan, who have contributed so immensely to the space science. According to Dr. Vikram Sarabhai, technology is not an object to be aimed at, but a tool to be used for the benefit of the common man. He who can listen music in the midst of noise can achieve great things. The development of the nation is intimately linked with understanding and applications of science and technology by its people. And this particular quote from Dr. Vikram Sarabhai is really so relevant even today. He made it in the 1960s. There are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with the economically advanced nations in the exploration of the moon or the planets or manned space flight, but we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the applications of advanced technology to the real problems of man and society. And paraphrasing a statement by Professor Satish Dhawan, those who do not have vision, there will never be a problem. Those who have a mission or a task ahead of them, there will be innumerable problems that will be cropping up that will be of varying magnitude. And for individuals, the problem should not be the masters, but the individual should be the masters of the problem. They have to handle it, they have to deal with it, they have to defeat, and ultimately they have to succeed. So with these remarks of the great quotes from Dr. Vikram Sarabhai and Professor Satish Dhawan, now I request our Chancellor and other dignitaries to proceed to D501 for the formal inauguration of the ground station control of Ramayana satellite. And after the formal inauguration of that, please assemble here for the presidential address by our Chancellor and the other events. Thank you.
Yes, then actually we have to just result on this thing.
Welcome back, everyone. Dr. M.R. Jairam is the Chancellor of the University and Chairman of Gokula Education Foundation GEF. Dr. Jairam is the eldest son of Sri M.S. Ramaiah. GEF was established in 1962 with the mission Education and Health for the Better of Mankind. GEF over the years has established 21 institutions on 85-acre Nanakangotri campus. The institutions include engineering, medicine, nursing, dental, law, management, and so on. You find almost all disciplines on a single campus. Today, more than 14,000 students study on this campus. He is not only an educationist but also a businessman and industrialist of repute. He is also the chairman of Valdel Corporation, which is into engineering construction, engineering design, retail, BPO, and host of other businesses. He is also into community development and philanthropy. He is the Dharmadhikari of Kaivara Kshetra, a center for religious activities that is situated around 60 kilometers away from Bangalore. He has created a trust that awards scholarships annually to the financially backward meritorious candidates for pursuing higher education. Dr. M.R. Jairam was awarded honorary doctorates from Coventry University, UK during November 2006 and University of Illinois, Chicago, USA on 6 May 2022 for his contribution to promoting higher education and healthcare services. I now kindly request you to deliver the presidential address, sir.
surrendering myself to the divine. The chief speaker of today's function, Dr. Chandra ji, guest of honor, respected Dr. A. Pillai ji, experts, Dr. Ashish Kushuji, Sumit Soman, the Vice Chancellor, the Chief Executive Srinivas Murthy ji, Vice Chancellor Dr. Raina ji, the Pro Vice Chancellor Kadambi and Kalpanda ji, the members of the faculty of all the faculty members of our university institutions, and more importantly the engineering institutions and students and the guests who have come to be in this function. It's a very important event for us today. We are just closing the centenary celebration of our founder, Sri M.S. Ramaiah. And what best that we can do is to dedicate imbibe the young minds of making something which is very important for the future technology, and for you to be there, the set which you have able to build and which today you have also you have been able to see how the movement has taken place, and so we are just with the help of Dr. Sivarathan Pillai, we have been able to have this done. So congratulations to all of you, and I think this is a very proud moment. Having said this, I think I have to, as a chancellor, I would like to, this is a very important event for us. The event is that the new world has now taken over. Technologies are becoming more important. Innovations are becoming more important. And more importantly, I think the knowledge itself is undergoing a tremendous change. A movement of knowledge from continent to continent is taking place. I think India is the place where the shift is now taking place and it's coming back to India. So what are the challenges that the universities have? Are we going to be in that change, or what is our thinking on this matter is very important for us. I would like to go back to saying that this has been a very important thinking process for the last 20 years. It is not today. What we are seeing today is what we have passed through the last 20 years. The biggest challenge that we were thinking back in about 10 to 15 years back was, having run the engineering institutions for more than 50 years, having 30 years medical institutions, health sciences, general sciences, and all the engineering sciences. One thing what we could find that change was, when compared to the Western countries or the developed countries, was how do we apply this knowledge? The application of knowledge was becoming a very big, something new to us. We are very good in theory. Theoretically, we are very sound, but unfortunately, we had somehow not made it possible to implement the implementation of whatever that we have learned, put into practice, or what in modern terminology we call as innovation, was not to that extent. So to do that, first of all, we have to learn from somebody how the innovations, how the applied sciences takes place. How to apply the natural, the law of or the learning process, and along with that, how do we do this? This is a big challenge for us because that was something new that we found. So what we did was, many of the institutions in this country, even IITs, were not very proficient in this. Though they just at that time they were just thinking about it. So we thought that unless we get into partnerships and trying to bring the knowledge people into it and learn from them, that's the only way that we can do it. That's how the School of Advanced Studies started. It was started with just without anything, because we did not go to the government of India, we did not talk to anybody. There was no law. We took that privilege that there was no law to prevent us from getting this type of collaboration, and we brought it and we made it happen. And one thing that shook us, or I was taken aback, after about 4 to 5 years, they had only one, the postgraduate on manufacturing science, in MS in manufacturing science. I thought that was the importance for this country, because manufacturing was taking place and we didn't know how the technology of manufacturing. So that's how that university was expertise on that, and there was only one postgraduate department which was very well recognized. So we said, why not you give us that? They said, no, we are not. I don't think you are ready for it. We are prepared to give a management course if you are interested. I said, we are not interested in that, you can go back. After 1 or 2 years, they came back and said, no, we are now rethinking, why not we come together? So I said, fine. So that's how the School of Advanced Studies came into existence. When it came, we started this first program, was the Masters in Manufacturing Science. Later on, then there was two important people in that university. Both of them were Asians. I don't want to name them. And they were keen, and one was a pro-vice chancellor, and they was very keen that we must do something. You have such a huge, mind, and such a open thing that you can have this thing. And so he encouraged us. Why not you start other postgraduate courses, though we don't have in the university? You can start it, we'll help you, and we'll get it accredited in UK by the government of UK with that collaboration with that university. Like that, about 8 to 9 courses was done, developed, and it was accredited by the British government, and it was adopted by that university. So it was a reverse, but it happened. That time, it was, I felt that yes, we can do it. So it was not something which cannot be done. So I felt that this can be done, and that's how we started thinking about it. In the meantime, there was so many other problems. The government of India came and said that you cannot run a program without our permission, and without the way the structure is very. It is not acceptable to us, because even a diploma student who has got 5 years of industrial experience can go and get into masters. They said it's not just possible. So they said you must stop that program, and we had to stop it. So there was no other go but to start the university. That's how the university came into existence. So this is all a story which is one by one it's taking place. So when we started this University of Applied Sciences, and we named it as Applied Sciences, but the problem was the structure within our government of India was very, very stringent. So it was immediately to apply this to this structure was becoming a bit of a problem. So it took us a lot of time to change over this. The faculties, the question was who can deliver, was allowed to do it. But here we had a structure. We had the policy, they had to be postgraduates, they had to be not only postgraduates, they had to be PhDs, we had to get PhDs. And all this, whatever that structure had to be done. So this changeover, when it came, it took us backward. So again it started, and we started, applying these things. And today, with so much of the drawbacks and the ups and downs, and we have seen all these changes, I would say that we have come to a time when, yes, we are ready for it. I think we are, the university has got enough strength to withstand. We have strengthened the university to a very great extent. We have all the three sciences: engineering science, medical sciences, health sciences, and social sciences. All these three have come together. So it has become a holistic university of having number of institutions of all your subjects into it, multilateral subjects into coming to this university. So, and the strength has become, financially it is very, very viable. And number two is we can now think of integrating of innovation and research. Having one is just, I don't think it's going to work out. Science is now, the holistic approach to science is very important. Everything has got, applications. When you start application, it could be for medical sciences, it could be for general sciences, it could be for innovation, for engineering sciences. See, many things all these things have changed, when satellites were put and when the man went to the moon. That's what they said, the story, that they invented so many innovations to check a man's body. And that's how the whole health sciences changed. So the change has taken place, a very big change has taken place. Now, we are now in the position to say that yes, we are in a state that we can think of growing. The question is, what is the future? That's the biggest challenge that we have. And as I see that innovation is going to be a very big issue for us, or the vision of our innovation will be a very big. We have to now think about how we do it. They have also started the public policy. The reason of starting public policy was integrating our thinking process. We have to bring the social society, the science, and integrating and defense. What are all these things, all economics, everything has to come together. So therefore, the public policy we have started it. And the outcome of this public policy was, we were now thinking of having innovations, our center, I'm sorry, I'll come back to you. I'll come back to you in a few minutes. Strategic studies. Yes, I'm sorry. It's slipped my mind. The strategic studies was one of the outcome of this. We thought that we wanted to be there. The reason is the defense is becoming a very big subject, and we wanted to be a player in that. So strategic studies was the outcome of the public policy. The analysis from one end to other end, we wanted to see how can we bridge all these things and bring them in together. Now we are putting the best mind, building up of that strategic studies department. It may take about 1 year because we have to hunt for the best minds. So we are not in a hurry, and we have taken Dr. Pillai, and his advice has been very, very useful to us. So now we are trying to put all this into correct perspective. Now the next was about the innovation and technical center. These are two things that whatever that we have seen in the foreign country, whenever we visited most of these the best of institutions. I think everywhere we see the innovation center is a very big in most of these universities. So we wanted to have an innovation center, which is again going to be, innovation means training and innovation. So it is going to be both. So this will be one of the verticals. The academics will be one vertical, and innovation and techno center will be one techno center which contains innovation and training, which will be one vertical. So this is our vision for next 3 to 4 years, and we are looking at it in a very big way. All that what we want is the correct minds, the mindset, people who have got passion to work. That is the type we are now searching for them. Wherever we find that, we are going to do it. And to do that, the policy has been now, the vision has been set. For implementation, we don't want to put any wrong steps. We have gone forward, backward, gone forward, gone backward. All these things have happened. So it has given us a lot of experience. Now we cannot go backwards anymore. I think we cannot afford to. Whatever that has to be now fulfilled, we have done. So we have to only go forward. So we are looking at in next 5 years, we'll be having in this campus, this will be about 2.5 to 3 lakhs. It will be going to be a completely techno center. Innovation, training will be a place for this. This is a hub of industries. It is the center of industrial area. This is the right place where these things can happen. Academics, we want to have a new campus which is up, which is going to be a most campus which is of the future. All the students will be the students in the university. There will be students who will be given accommodation by our hostels, all India, and students are going to come and stay here. They stay for 4 years, and that type of the faculty will be there, and the best mindsets we would like to get. We want to get into all this type of a new thinking which is going to happen. That also we have started, and if possible, we are collaborating with some of the foreign universities which are within 50 in the world ranking, and some of them, if they are, I think they are showing a lot of interest now, we want to bring them together and see that this can be happening. So this is what is going to happen. I'm trying to tell all of you that we don't want to keep anything in hiding. We want to put everything in facts and what is our thinking. And after having said this, I think all these things will evolve. And what we are now looking at more important things. I think even our faculties have to a lot of changes to come. The passion for creating something has to come. Otherwise, I think we will be losing the golden opportunities that has been given to us. So we are looking at it, how to do that. What is the way in which we can do this? And all these policies will be coming out in next 1 year or 1 year or 2. As far as the techno center is concerned, I would like to. What I saw in the Western countries, many of the universities have tied up with 1 or 2 big industries who want to develop one end to end, completely devoted, and they want to develop that technology, which has helped them to a very great extent. And I've seen this happening in university. It is not a multi industry going everywhere. No, they are concentrating in some university. They have said, yes, we'll be there with you. We want to end to end. We want everything to be done. So we are going to be partners in this. That is what I'm really looking at. I'm prepared. As I said, training is one of the major things. That's why I said Techno Center will have a training component and innovation. Both these things will be together. If any industry, as we are doing for studies, even there, we would like to see that one end to end, where we take up the subject with the help of the Ministry of Defense, study them, train them, evolve, innovate them, make a product, and give it back. So it is one end to end. So this is the type in which I think now even the government is also very seriously thinking. I think even the industry is also now thinking that they have to. I think if there are some universities are prepared for this type, I think I would say, with all humility, we may not be that big. With all humility, I would like to say why I'm looking at this topic is that can happen only with faculty who is inside, if you are not a passion. Otherwise, it will not happen. Let me tell you this. If you are thinking of mundane from today and tomorrow, and I simply sit here and get out of the place by 5 o'clock, that will not work. That can work only with minds, nothing else. That's why I said very carefully, I've thought about this. We need some time to get the right people to the right job. People who have got a passion for it. So we are looking at it, and we are looking at who is going to be a partner with us. We don't promise them anything because we are too small. But one thing I'll try to tell them also, that everything that we do, we'll do it with all sincerity, and we'll try to have that, whatever that their vision is all about. Whether if we can match them, we'll do our best. So it's open. We are open to industries, and we'll talk to them. And if there is any interest shown, we'll more and more we'll discuss with them. And also build the institution around them. I've seen the top 3 to 4, the best universities in the US have been built by some of the top, these industries. This is a fact. So we have to be partners, and for that's why I'm not in a hurry. Let me tell you this. That's why once if we come to that, then we'll create that atmosphere of creating how it can be done. So this is our plan. Pathway has been set. So we are now looking at the partnerships. Now, this is centenary year. One thing that today I would like to, we have spoken to. I've taken the permission. Please, let me tell you, it is not my own. I have taken the permission of all of them, because if the Vice Chancellor doesn't agree, then what is that I'm going to do? So I said, are you ready for it? And the advisors, Mr. Srinivasmurthy is there, Dr. Pillai is there. If they don't take it, what is that I'm going to do? So I just took their approvals, and So one of the thinking process that today I'm happy that Girish Chandra, I mean it was more inward looking from his talk. He started with quantum mechanics or quantumizing, where it stops, metaphysics starts. I'm more a metaphysical, I'm not a very, just a beginner, don't worry, I'm just a small. But the thinking that is only this country can think beyond, no other human race can think beyond this. All of them think physically, but we can think something more. That can change the world. So, and he did so, and his last, his slide was most interesting to me. The yogic
Inner peace of
inner peace of mind. That yogic. That is the beginning of metaphysics. Am I right, sir?
Yes.
So, I would now what we can with all the permission that which they have approved, but it will be coming out very shortly. We will be starting a PG program in quantum computing technologies. For this will be for 10 students or whatever that the AICTE approves and gives us. This will be done. Let me tell you a little bit of more, this may be just open, but what we have discussed, I'll let you know. These students will be on all India basis, which will be very highly publicized. And the students who are selected, the university will pay the stipend for 2 years. They will be in the hostel. We'll give them the hostel. 2 years of stipend will be given them. And they will be with us. And we will have the industries collaboration, where they become the visiting professors, and we'll have their participation is very good. So what we are trying to do, let me be very, what we are trying to do is, we are doing two things. One, we need the best of minds. If a university has to grow, we need the best of mind among students. Then the faculty also will come there. To do that, we thought that this is the best way of doing it. For starting with the subject, which is very important to all of us, to this country. And once you have one center of excellence, then automatically other centers can grow. So I want to start with a small way. This is a beginning which we start, and we'll try to see how we can really implement this. In next at least 5 years' time, we want to see at least about 50% of the students are taken on this basis for PhDs. And we'll ask the industries to sponsor them also. So 50% will be done by us, 50% will ask some industries to sponsor. Like this, can we extend for PhDs program and master's program? In selected master's program. This is a slow growth, but I thought that it is a workable growth. We can really grow on this basis. If we are able to do that, I think we can bring that, the knowledge, it's a two-way. It is from faculty and students. Both have to join together. So that can happen only, I think this is the best way that we can do this. So let us start with this next year. That next academic year, I would like to start this. And all I think the governing body will take the decision of what are the procedures and all that is left to them, and they will take care of it. And the second is that I told you that next 5 years, the center of techno center is going to be one of the major next 2 to 3 years. We are going to have training and the innovation center, and the strategy studies will be a part of it, one another center. So there are 3 centers. This whole campus we would like to keep it for that: techno center, training center, and and for strategy studies next 3 years. So this is our plan, and we would like to get into this. So with this, I'm happy that we had great minds. The philosopher and guide has been here. Mr. Pillai has been talking to us. He has given so much of inputs to us, and we value his advice to a very, very great extent. And we need his help, and he will be a part of this growth. Let me tell you this. And whatever this today, the satellite, it is his. He is the man, and he made this happen. Sir, I salute you. And on behalf of the Gokulajian Foundation, I pay my respects to you. Thank you very much.
On behalf of everyone, I would like to thank you for your time, sir. Your presence has been very valuable to us today, and we certainly look forward to another interaction in the future. I now invite Dr. Govind R. Kadambi, PVC and Dean FET, Ramaya University, to please deliver the vote of thanks.
Distinguished keynote of today's function, Dr. Chandra, respected Pillai, respected Chancellor, CE, Vice Chancellor, Pro Vice Chancellor, Deans, and keynote. Apart from keynote, we are also having the expert sessions by Dr. Ashish Kushu and Dr. Sumit Sogan. Dear colleagues and friends, it gives me great pleasure to propose a vote of thanks. As all of us are aware, the success of any function is a synergetic and symbiotic union of responsibility sharing shoulders, helping hands, and more importantly, unwavering inspiration and support from the bottom of the heart. Okay. So if you have seen any success so far in today's function, all the factors what I have enlisted are embodied in it. With this, I propose vote of thanks. We had a illustrious session by Dr. Chandra, and our Chancellor did plan some of the activities in the near future. That itself is an indication of what we have stimulated through your talk. Okay. And on behalf of our university, on behalf of all the participants of this function, and on my personal behalf, because I know you and you know me since last almost 16 years through our association from School of Advanced Studies and University of Applied Sciences in the form of mentor and others. Sir, I profusely thank you for your excellent keynote address. As a token of appreciation, I would request our Chancellor to present Dr. Girish Chandra a moment of please.
Back it off, it'll open it up.
We also had a very interesting remark and address by our Professor Emeritus and also long associate of our University and the School of Advanced Studies, Dr. Pillai. Apart from today's the inaugural remarks, we will also be presenting a session and also will be moderating our panel discussion later in the day. Again, as our Chancellor said, actually he is a man of vision and enormous experience, and he has the rare distinction of having worked with the three great stalwarts in space science, namely Dr. Vikram Sarabhai, Professor Satish Dhawan and Dr. Kalam. Actually, in every meeting we can see the reminiscent of his association. Again, on behalf of our university and all the participants of this function, I profusely thank Dr. Pillai for having graced this function and for his inspiration to take this Ramaya satellite as a part of the 75th at the Azadi Ka Amrit Mahotsav and also the bicentennial for founder Dr. Ramaya. Again, sir, I request our Chancellor to present a memento as a token of appreciation. We are also fortunate to have the gracious presence and very inspiring address by our Chancellor. Needless to say, why we are here and what we are here are entirely due to his vision, and is a voracious reader and a great thinker, and the plan that which he has laid out for the university and the group are reflection of his thought-provoking ideas within him. Again, on behalf of our university and all the participants of this function, I profusely thank our Chancellor for gracing the function and for having inaugurated the Ramyan satellite ground station. As a token of appreciation, may I request our Vice Chancellor, Professor Reina, to present a moment to our Chancellor. Chief Executive of Gokula Education Foundation, medical and highly experienced IAS officer of our state and country. Actually, is helping the university and group in numerous ways, and he has always been the supporter and guiding spirit for all our initiatives. So despite the engagement, actually at least he was very particular to see that he's a part of this function in seeing the inauguration of our Ramaya satellite ground station, sir. Again, on behalf of our university and all the participants of this function, I profusely thank Sri Srinivas Murthy for his gracious presence. Now I request our Vice Chancellor, Professor Reina, to present a moment of this.
Thank you.
Dr. Razdan, who is an advisor to our group for quality and accreditation. Obviously, now that is without quality, there is nothing that we can do in any industry, particularly in the field of education. And he has been the spirit to move ahead in accreditation and ranking, and has always been a constant thinker and giver of ideas again. Again, on behalf of our university and also all the participants of and my personal behalf, again, profusely thank Dr. Razdan for having graced the function. I request our Vice Chancellor, Professor Reina, to present a moment.
Sure. Your Honor, thank you very much for doing this. मैं आपको दे दूँगा, आप दे दूँगा. Thank you, sir.
As our Vice Chancellor, Professor Reina, does not require any introduction about his initiatives and thinking, and he has been active supporter of all these initiatives which will bring value to the students, value to the institution, and value to the country again. So he has been completely supportive and has taken keen interest in this program. Again, on behalf of our university and all my colleagues and all the participants of this function, I profusely thank you, sir, and I request Krishnamurthy Jaina to present the moment to our Vice Chancellor.
We're all hosts, I think, you know.
Dr. Karbanda, who is a Vice Chancellor, Health Sciences. So he was also there, and he has bringing a lot of his expertise in his previous stint in All India Institute of Medical Science, and also he is also a very keen thinker and I could say adapter of the evolving technology. I'm sure the talk by Dr. Chandra would have impressed him much more. Again, on behalf of our university and all the participants, I profusely thank you for your gracious presence. Now I request our Vice Chancellor, Professor Reina, to present a moment to Karbanda.
What could be the best outcome?
Thank you, sir.
Thank you very much. Some other day.
Our Registrar, Dr. G.S. Venkatesh, is an able administrator and a very silent supporter. Actually, in fact, for the last 1 week, he has been constantly asking me, do you need any support from your university for this? Okay, sir, I thank you for all your support, and on behalf of our university and also the participants of this function and the group for this ground tracing control, I profusely thank you for your support. Sir, I request our Vice Chancellor, Professor Reina, to present.
He said silently doing. He's not doing everything silently. Thank you very much for being a part of this. Thank you very much.
We also have the presence of Dr. Meda Rao, Dean Academics, and she has graced the function, and she was also very curious to know about the satellite program and the ground station. Again, I back of our university and all the participants, I profusely thank you, madam. May I request our colleague Jyoti to present a moment. We also have two industry professionals and experts in their own domain. Dr. Ashish Kushu from Electric Technology Services and Dr. Sumit Soman from Ericsson R&D. Following this session, they will be delivering the technical expertise lecture. And sir, on behalf of our university, on my personal behalf and all the participants, I profusely thank you for having accepted our request at a short notice and for having agreed to deliver the technical sessions. Thank you. I also thank our finance head, Udai Kumar Shetty. Actually, in fact, he has been very kind and very dynamic and has been supportive of all the activities of this. Again, on behalf of my colleagues and all the participants, I profusely thank you for your dynamic support. We also have sponsors for this event. Actually, two of our incubators from Ramaya Technology Business Incubator, Mvega and Printalytics, they have sponsored it. Apart from that, also we have a sponsorship from Indian Technology Association for that they have also sponsored. Again, on behalf of our university, I profusely thank ITCA, Mvega and Printalytics for having sponsored this program. And as we are speaking about 210 students from Cambridge English School, they are participating in various events like debate, painting, quiz actually. I also profusely thank the chairman and the principal of Cambridge School for having taken initiative and interest in supporting this program through their participation. I also thank all my colleagues, despite the varying nature of assignments and commitment, they have always been forthcoming and they have shown the sense of belonging. And I, personal behalf and on behalf of the entire team, I profusely thank all my colleagues and office bearers, including the deans, HODs, for their active support and participation. Obviously, university is the synonymous with these our students, and I'm sure there has been a overwhelming response from the students, both online and offline. Again, I take this opportunity to profusely thank our students for their participation. And I also thank all the delegates who have joined this program, through online also. And I profusely acknowledge the support of our ICT team and the facilities who have been working tirelessly for last couple of weeks in seeing that this ground station control gets in time for the formal inauguration. I thank each and every one of our ICT and facility team for their continuous support. I also thank my colleague Sarna Shankar for being the master of the ceremony, and also Ms. Vaishnavi for the inauguration. And I also thank media personnel for covering this event. And on a generic grateful note, let me thank everyone and anyone and all for their support and service. And Chancellor has made many inspiring remarks. Just to substantiate or complement it, let me quote one statement from Dr. Kalam. If you want to shine like a sun, you have to burn like a sun. And about the quality of Indian mind and quality of Indian thinking, let me conclude by paraphrasing a statement by C.V. Raman when he was addressing a group of students in Chennai. Paraphrasing his statement, I urge young men and women not to lose hope. The success to your task comes through unwavering dedication. Without the fear of contradiction, I can say the quality of Indian mind is equal to that of Nordic, Anglo-Saxon and Teutonic. What we lack perhaps is the courage, and what we lack is perhaps the driving force that can take anybody. We need a spirit of victory. If that indomitable spirit of victory were to arise, nothing can stop us in attaining our destiny. With these remarks again, I profusely thank all of you for your participation. Jai Hind, Jai Karnataka, Jai Jai. Thank you.
Thank you all. We shall now be taking a small tea break of 15 minutes, after which we shall join back in the same auditorium for expert lecture sessions by Dr. Ashish Kushu and Dr. Sumit Soman. Thank you.
Thank you very much for doing
Good afternoon, everyone. For the expert lectures talk, we have with us Dr. Sumit Soman here today. Dr. Sumit Soman is currently working as a senior data scientist with Ericsson R&D at Bangalore. Prior to this, he worked with the Health Informatics Group at the Center of Development of Advanced Computing since 2011 in various capacities. He holds a PhD in machine learning from IIT Delhi and is a senior member of IEEE. He is the chair of the IEEE Bangalore Section Censors Council and Exicom member of the Young Professionals Affinity Group. He has published several research papers and patents and is also an editor of IETE Journal of Research. He is also a voting member of IEEE Standards Committee Working Group on Reporting Standards for in vivo neural interface research and the IEEE Industry Connections Group for neurotechnologies for brain-computer interfaces. His areas of research include machine learning, AI for telecom, and health informatics. He is also the recipient of Director General CDAC Young Innovator Award. So thank you for joining us because of your extremely busy schedule. You have come from so far. We are waiting to listen to you, sir. I request you to please give your talk. Thank you.
Hello everyone, good afternoon. It's a pleasure to be here on the National Technology Celebrations at the campus, and congratulations on the inauguration of the ground station as well. Thanks Dr. Rinki for the invitation as well. We have been planning this for some time now, and unfortunately I was planning to leave earlier today. So just a quick talk. I will not go into a deep dive on any technical aspects due to scarcity of time, but maybe just touch upon some of the aspects. So in terms of, today Technology Day was, of course, it's celebrated and there are a lot of associated events that you would like to have. So I would just quickly like to talk about some experiences that I had when we were starting off on a new research domain. So this was way back in 2010 when I was working with CDAC. Health Informatics Group I was working with, and we had one R&D project where the idea was to develop brain-computer interfaces. So I did a lot of work at that time. It was in its infant stages. There was very little research in India, and we started off working and exploring on these aspects, like trying to do so we were all computer scientists at that time. We did not have too much idea about signal processing, neurology, and all these domains. So we started exploring into available literature. We tried to do initial prototype, replicate from public data and so on. And we built a prototype. Like we were able to do some system that people could wear on their heads. They will record the EEG signals and they'll be able to move a mouse cursor. That was our idea in the beginning. And what we thought is that there's well-known neurological literature that says that event-related desynchronization is a phenomenon, and we should be able to capture that in EEG signals and build a system using that. So while we were able to build a sort of prototype from what was available in literature, replicate those results, when we actually started to use these on people, we found that this is not working. In the sense, the classification accuracy of the system, the recall precision, all these values were not something that is of practical use. People were making and the system was making a lot of errors because the variability of these signals. The nature of these signals that were collected in real time is very different from what is there in clean data that is available publicly. So in this setup, now we had to sort of refine, we had to go back to the working board. We were basically engineers, but this was an interdisciplinary subject that not only required CS and EE kind of expertise, it also required neurotechnologists, neurologists to be able to work in a collaborative manner. It is an interdisciplinary field. And that is when we started working with doctors, and we started looking at these signals with them in the recording labs and the EEG labs. And we try to understand what are the basic things they look at, how they are able to discern between patients and normal people and all those aspects. So once we started gaining insights into that, then we went back to our system, we refined it, we worked on more detailed architectures, models. We even changed what we wanted to detect. Initially, we thought we'd be able to detect human thought and some specific aspects of that. But what we eventually built was a system that could detect eye blinks and eye movements, and we could have a system that could detect that. And then we went back to the hospital, we went back to the neurology department, ran this on patients, and there were people who had spinal paralysis and they could not move their limbs. And they were, even though they were educated and they had done their graduation and they were computer literate, so as to say, but they could not operate these physical devices because of this locomotive disorders. And when this system was given to such people, they were, of course, it takes some time to adapt. There is a learning curve, but eventually they are able to do basic operations on the computer. The quality of the life and how they interact with systems changes significantly. So even though we struggled for, I think, 3 years trying to find out what all was the thing to do, what was the right path, but eventually, if whatever work we do, however technology we adapt and bring it for human impact, that is where the key outcome and the satisfaction that you derive from your work lies. So just wanted to share this experience with you all. I know I won't take up much time because you and I have to leave, but just wanted to share this experience that we should always be perseverant, no matter whatever roadblocks we hit, it will be eventually very fruitful to benefit the end users and give them a solution that will impact them in their life. So just to recall this experience, it was a pleasure talking to you all, and my best wishes on National Technology to all. Thank you very much for having me.
Thank you, sir. I now request Dr. Rinki Sharma to hand over a memento as a token of appreciation to Dr. Sumit Soman.
Sir, thank you so much.
Thank you.
Thank you, ma'am. I now invite Dr. Jaihar. I now invite Dr. Jaihar Sivasubramanian to introduce our speaker, Mr. Ashish Kush.
Good afternoon, everybody. Our next expert speaker is Mr. Ashish Kush. He's a Chief Technology Officer at L&T Technology Services, and he drives the company's technology and innovation strategy and investments to develop IPs, platforms, and solutions. LTTS is India's largest pure-play engineering services company and an acknowledged technology leader in the space. Innovation at LTTS has been recognized and awarded by many leading organizations. Mr. Ashish has always been working in domains and industries strongly influenced by technology disruptions. His experience spans technical and high-performance computing, network computing, and product engineering services. So with over 32 years of experience, he has developed a holistic view of business and has been instrumental in adoption of new technologies at scale through change management. So I will invite you, Mr. Ashish.
Good afternoon to everybody. I know I'm standing between lunch and so many sessions this morning, never easy. Also, it's a fairly mixed audience. So I thought what I'll do is just share with you some insights out of the experience that we have for you people to just take away and draw your own conclusions. Every day in the morning you get up and you read about a new technology disruption that is happening. It looks like the world is going to come to an end, right? And every day you get up, you have people who talk of a new technology as if it is here, now. You don't do it, you don't know of it, you're irrelevant. I think this whole thing, and as you heard by your chairman as well, talking about various plans. It's very important, very, very important to understand the landscape in which we are operating. The landscape is the economy in which we are operating. Technology feeds itself. If technology gets adopted well, it progresses. If it does not get adopted well, it dies. That's it. There's no simple, there cannot be anything more simpler than this. But you also then need to peel the onion to remove the hype and figure out what you want to do and how you would like to remain relevant in the domain in that you are working. So a few points, and then we'll connect the dots as we go forward. Point one, startups is not new. It's been there since mid-60s. It's new for us in Bangalore. Not even new in Bangalore because startups in Bangalore started much earlier in 2000s. And when people were getting sacked in 2000, 2001, you couldn't tell anybody because that was a social stigma in India. Now it's no longer a social stigma. You can still get married if you're not working. You can still have parental support. Point is, it's not new. So you don't have to associate issues of complexity and if I don't do startup or if I'm in a startup, the world will not come to an end or the world will come to an end. It does not work that way. So that's one important point. The second important point is, what choice do we have? I've been saying this for the last 10 years, for sure, that GDP makes no sense. What makes sense is per capita income, which means that per capita income for each one of us today is around $3,000. China is at $13,000. Western economies are at $54,000. So what you see ahead, the train has left the station, it will grow. It will grow. It will grow. There's no debating it. Whether you are there, I'm there, we are not there, it will grow. That means 30 times bigger economies. 25, 30 times bigger economy in your lifetime, in my lifetime, not so much, but perhaps in your lifetime. So growth is inevitable. And it will happen. So the question is, if growth is going to happen, technologies are going to keep evolving, what role do I have to play? How do I prepare myself for that? Now, if I have to spend some time thinking this. Unfortunately, this is where we fail for various reasons, and the failure is not because we don't think of it, it's just the structure of an economy. Now, what happens is, before I come to some of these things, the other important aspect is that we as a country have grown in a very linear manner. I'll do X, I'll go to Y, I'll do Y, I'll go to Z. Correct? It's a very linear growth, linear way of thinking. But when you are talking growth, when you are talking technology changes, when you are talking growth in the size of markets, when you're talking for global integrated markets, you ought to have a more multi-dimensional view of how technology is going to evolve. That's very, very important. Computer science is more hyped up in India because it gave a huge boost to the economy. But it is like light. You take electricity and you put it to different uses. That's exactly what you do with computer science. You use computer science to put it to the right uses. That means mechanical, electrical, electronics, instrumentation, space, automotive, all these functions, all these disciplines will require computer science and they will drive the application of computer science, not the other way around. So no discipline is going to disappear. That's another important aspect as we look into the future or as we look into what's going to happen. But in this whole noise, what's happening is that we're getting so carried away with the hype around cloud, IoT, AI, ChatGPT, large language models, the works. It looks like there was no technology till yesterday. But technology is a continuum. It evolves. Somebody creates it, it gets adopted. As I said earlier, If it finds customers, it matures, and if it becomes cheaper, it gets adopted, else it dies. Time are dozen such examples throughout. Now it is in this particular domain, in this particular landscape, we need to figure out what is it that we want to do, what exactly is it should be our approach, our game plan, etc. etc. It takes time to figure this thing out, but you have to be aware of it all the time. Nothing is going to change. It's the most exciting time in the area of technology because it has got commoditized. It's become cheaper. I was telling Dr. Girish, quantum computing today, it's not happened today. Sorry. It's evolved because of what once used to be supercomputing, once what used to be HPC, and it's going to frontiers that has never gone before. But guess what? A supercomputer, when I worked on a supercomputer as early as 1990, the power of that supercomputer was lesser than the power which is available on your iPhone or your Samsung phone. That's how technology moves and matures. So your strategy, the strategy of the institute, the strategy of your personal life or your studies or your how to keep these things in mind. I left one sentence earlier, halfway, which said that unfortunately we look at it very linearly. I'll come back to this in a while. So what is happening around the world? The confusion that you have, you professors have, I have. I can't speak for my friend Dr. Girish from TCS, but I'm sure TCS as well has. Everybody has. Everybody is swimming in the same swimming pool. That's a big positive. There is no leader. Everybody is exploring new frontiers, what to do, how to manage at the same time for the first time in human civilization. Do you now realize the opportunity it presents to us? We could be leaders. We've never been leaders so far because everybody was leading and we were jumping in the pool much later. That's one. The second advantage that we have is that everybody in the world, as I talk now, is innovating on the same topics at the same time with the same degree of proficiency. So you're not alone. So when you read that newspaper junket, they have no clue what they're writing and trying to confuse people. The Koreans, the Germans, the Japanese, the Europeans, the Indians, the Silicon Valley, they're all in the same boat. Fine, I mean, somebody may be ahead in the boat, somebody may be behind, that doesn't matter. Now look at the opportunity that we have. Everybody exploring technology for the first time in the history of humankind without anybody having leadership. Everybody learning at the same time and innovating at the same time. So who wins? What will make us win? Let me come back to my earlier point. There is an issue about innovation. You can't start innovation tomorrow, just start it off a whim. Let's switch on the light and here we are. Innovation is a culture, it's a soft thing. How do you develop it? What do you do to become innovative? What do you do to become creative? It's a process. Unfortunately, for a large number of us, and it's a societal thing, it's an economic thing because of the nature of, and it's a part of every growing economy because you're bothered about today. But now if you have to win, your strategy out to be what do I want to do day after tomorrow. You may say this is Gyan. Well, fine, no issues at all. Gyan for you. I didn't do it in my company. We've been thinking about it for the last 9 years and we are ahead. It's difficult. But don't we do that in our daily lives? Think for a minute. When we've seen our parents build homes, don't they build a house and put a space for a TV or put a space for 2 car parks or 1 car park without having one, and they say, when I'll get the money, I'll buy. That's how the Indian society has been. So why can't we apply that simple vision, rule of vision to our personal careers, personal choices, and the way we work in our companies? That's all it requires. What will make me relevant 3 days from now? You don't have to spend 100% of your time there. But you have to spend 2% or 5% of your time on that particular question, and everything starts falling in place. You don't have that, keep crying. You can run on a treadmill, but you never actually cover physical distance. Keep running on the treadmill. You'll be as fit as I am, but I would have reached 10 kilometers from here near World Trade Center while you're still standing here. You're not running on a treadmill anymore. This is the simplest cultural change that is required. You can, I'm sorry, I'm not telling you, you can start an innovation culture, you can start a course, you can do many things, but if you do not know what is going to hit you 10 days down the line, you have no clue about the success or the failure of whatever you're wanting to do. And it applies to your choices in career as well. If you're Gen Z or millennials, whatever, stop complaining and expecting college professors and college staff to solve a problem that they're still figuring out, and I'm figuring out, TCS is figuring out. You expect the college to figure it out? No way. I'm not able to figure out. So go get out there. Figure out yourself. But these are subtle changes that will drive. This is the only formula as engineers that you need to apply. You need to go back to your engineering capabilities. If, then, what, how, put a structure in place and just follow it step by step. And you'll get this right system and there'll be no problems at all. Confusion arises when you do not know what's going to happen in step 10. I mean, you're a mechanical or electrical or a civil or a computer science guy. Whenever you're trying to solve a problem, don't you have a methodology by means of which you first put it on a piece of paper? That's all we need to do. As you pick up a paper and it looks like the world comes to an end, I'll give you an example. There is a huge amount of noise in some sections in policy making. That AI, ChatGPT will disrupt the whole world. Sure it will. When? What will happen 3 years down the line? Which segment? Who will disrupt it? What are we supposed to do? Can you tell me how I can leverage it? No answers. Oh, there is India should make a large language model. Who in India will make a large language model? Who has the data? The government of India. Will the government of India give you the data? No. Why? Try giving that data and you'll have hundreds of NGOs fighting cases against you. So now you're telling me I should make large language model my career choice without even knowing what exactly are the practical problems. Who should, I'll give you maybe a slightly more simpler example. 6 years back, I, in my company, had a big debate. Blockchain is the way to go. I was very clear, I was the only one, and I pride myself on that. I turned out to be right, so that's why if I would have been wrong, I would have cited that example. I said, no, blockchain is not going to be big for us. If blockchain is going to be very critical, it will get implemented by two industries where it matters the most. One, money, banks. Second, governments for land records. If the guy who's handling land records does not implement blockchain, or if banks don't implement blockchain, do you think a mechanical engineer or an electrical engineer making 2D, 3D drawing will use blockchain to encrypt this data? I mean, what are you smoking? So I'm not going to I'm not going to invest even a penny on blockchain. Why? The criteria was very simple. If the technology does not appear in the horizon of my customers in the next 2 years of strategic investment plan, I'm not going to touch it because I know technologies will change every 3 months, 6 months, and it is not new. It's been changing much before I started my career 35 years back. So I'm not stupid. And look at what has happened. Where is it? Should we have invested? No. Very simply, when we look at some of the things that are happening around us, you need to take a pause, you need to go back, and you need to then look at peeling the onion and figuring out what is relevant to me. And the question that people are missing again and again. And it's sort of sad that it's getting good that everything else is coming to the fore. I mean, we've been saying this for the last 10 years, as I said. But another thing that we believe in, if you have to excel, and Dr. Jairam did say that, the world will require specialization for you to excel. Money will not be a problem. If you are specialized in even designing this very old technology of projector and you are an expert and doing something crazy about this, you will be valued a lot more than a jack of all trades. We are getting out of the era of jack of all trades. So no technology is dead. No stream is going to die. If you are an expert in one particular area and can dive deeper and deeper and deeper and deeper, fantastic. You are the person who will be cherished and required and paid the most. And the bad news is, you don't get there in 4 years. You get there in 7, 8, 10 years. You go and meet the Germans and you tell them I'm an expert after 6 years of experience. They look at you and they don't say, but you know what they're thinking in their hearts? We've been working on this particular topic for 30 years and here's a guy from India who comes after 5 years and he says he's an expert. No. And that's why they lead the technology areas in which Germans are producing fantastic products, fantastic automobiles, etc., etc. So the landscape is changing from this perspective. There's nothing else that is happening on the landscape otherwise, except that whatever was happening in the past is happening at a faster rate, it's becoming cheaper, and is available is available profusely to everybody on different media in terms of what's available. I think that is what we need to focus on. We try doing that in our company. We try doing that on a daily basis. I'll come back to AI. On a lighter note, how many of you watch James Bond movies? I mean, youngsters would have watched. Oh, he's also watched. Have you seen technology stories today mimicking whatever you've seen in James Bond movies? So poorly read people will write articles, and I'm very, I'm sorry, that's the only time I'm very hard-nosed, because I believe that when people write, they need to keep in mind that you're influencing a very large number of young minds and trying to create hype about them so that they don't even move out of their house. They think, why should I even touch this topic? It's so expensive. Real life mimics technology that is there in science fiction and in movies. So see more James Bond movies, or see Matrix, or see Alien, or read Isaac Asimov's I, Robot, The Rules of Robotics. It talks of a planet called Gaia, which is sentient, which has emotions. And what is the problem in AI today? AI is going to go sentient. That is why the Google engineer was fired. Half of 90% of the people would have opened what is sentient. So there is nothing so very dramatic about some of these things. It's just the old school of engineering. Go back to the basics. Go back to the basics. Take a pause. Figure out what's happening around you and don't get hyped up. So let's come back to the topic of AI. One of the biggest problems that AI has, and I don't know how many of you know about large language models, we'll drop that large language model discussion right now, is availability of data. Correct? Now I will risk something, kindly bear with me, I'm sure you people will know. Everybody has heard the word ML model, right? If not, it's fine. ML model?
Yes.
What does it do? They say you create a model about somebody, about something, and it predicts, right? And you train the data a lot more on that model, and then the model becomes accurate in its assessment, correct? Yes? Broadly? Right. So, when you walk into your class and you have a professor, and the professor will ask you a question day one, You don't know how to answer, right? Those people, right? By the end of the semester, you figured out what is the questions the professor wants. You figured out a pattern. You figured out a pattern about your mother, about your father, about your friends, about everybody in the class, and that's ML modeling which is happening in your brains. So when you look at AI, it is already mimicking human brains. There's nothing so very exotic about it. So now it's mimicking human brains. So when I'm talking to you, and I keep talking to you every day of my life for 30 years, so I have a fantastic model for my wife, vice versa. I know, we all know about our spouses, and we have a mental model of how my spouse will react to what I do. Now, if I create a mathematical model, which is incidentally not computer science, but largely mathematics and statistics which comes into play, I have to train this model on data so that it starts behaving accurately. Where is the data? That's the single biggest problem AI has today. So you say, I will create synthetic data, artificial data. I will create synthetic data, artificial data, and then I will start training these models a lot. The biggest problem is that till you do not get access to data, till you do not have data which is available for the models to be trained, it will not be very effective. So now here is the discussion on AI at 3 different planes. AI is going to change the world, it is going to rule the world, it will change humankind. AI is developing sentient capabilities, which is why a large number of people are saying AI will be dangerous to humanity. Then you have the third part, we have AI models, but we don't have data. It's very important, again, to go back and start peeling the onion. And once you start peeling the onion, things will become very clear. And the things that are very clear are very simply the same thing. Again, technologies are going to change. They were changing in the past. They are going to continue to change. And they will change more rapidly because innovation is happening across the globe at the same time by all set of people in a more inclusive manner. So it's here to stay. We have to live with it. Number 2, huge opportunity, because if everybody is innovating at the same time, you have a good chance to be leaders in that particular area. Number 3, if innovation, technology, creation, new technology things that are going to happen at the scale at which are happening and will become cheaper by the day, people who specialize and become experts in a particular area, true experts, are the people who will be most sought out in terms of money, career choices, etc., etc. 4th, India is a growing economy and it is going to grow like never before, and its growth vis-a-vis China's growth will be different because we will be driven by technology a lot more than manufacturing like the way China was. So we will be huge consumers of technology and huge contributors to technology. 5, there will be so much hype. You better get your notepads out. Maintain your sanity. Dive deeper. Don't go by headlines. Dive deeper. Understand the topic. Understand its relevance to you. And then decide what you want to do. Next, innovation is a culture. It ought to be new all the time. You have to develop it. Read, write, contribute. Read, write, contribute. If you can file patents, fantastic. It's not about only filing patents, it's a process that you are allowing yourself to think. So read, write, explore filing patents. And last but not the least, computer science is not the end of the world. I am a computer science guy basically 25 years back, perhaps one of the first guys in the country, first few batches in the country. It's not the end all. It's going to play an important role. But what use is computer science to a doctor if the doctor does not decide in which area am I going to apply computer science? So it will be domain driven. It will be. So if you're a mechanical guy or electrical guy or electronics guy or chemical guy or whatever stream that is non-computer, you can still apply computer science and make the most of it. Computer science guy does not create cars. It's still done by the mechanical guys and automotive guys. They've not taken away anybody's jobs. And last but not the least, the jobs are not going anywhere. They will shift. Expectations from us when we work is changing. Typewriters didn't take away jobs. Desktop computers didn't take away jobs. Laptops didn't take away jobs. And mobile phones have not killed the mobile industry. They've killed a certain type of people giving a certain type of product. And outsourcing is not happening for the first time. Outsourcing has been happening for about 100 years now. As the economies grow, demands for jobs shifts. So AI will kill job. I hope it kills the job of people who write such articles. Maybe that's what ChatGPT will do. It shifts. The shift. How can jobs get killed in an economy which will grow 20 times? Can anybody make me understand that? India is at $3,000 per capita income. We are going to go to $30,000 per capita income. That's 10 times more. And jobs will get killed. AI will take away jobs. Come on, give me a break. That's no logical answer and confusing people. And the confusion is not only at the school level, at college level, at the student level, college. Even in our companies, this confusion exists. So you're not alone. They will shift. A certain category of people will no longer be required. You had people who write notes as stenographers. They would be available. Now they maybe use voice to record notes. There'll be other things that will happen, right? So this is how the landscape will emerge. Enjoy your technology day. Life is not so much of doom and gloom. AI is not going to take anything away. We are the ones riding the AI wave. Great opportunities, great amount of career, great amount of money is available. So much you can do. I wish I was your age. Just have a great time. Enjoy your college. Enjoy your studies. But remember, this is going to become a much, much more tough world in terms of competition. Excellence is the way to go. Excellence along with delivery of what you do, which has to match global standards. That is where we will have a huge problem. Delivery, we can achieve excellence, but can we deliver in line with the standards that the global audience is ready for, which is German standards, or American standards, or Japanese standards? That's perhaps more of a challenge for us. So that's all from my side. I hope you guys enjoy the future that is present in front of you. Thank you very much for having me here. Look forward to seeing you again.
Thank you, sir, for sharing your thoughts and insights with all of us today.
Are there any questions? Sorry. No problem. Because are there any questions?
Anybody has any questions for Mr. Ashish?
You call me Ashish. Yeah. Any questions? They're all scared. This is not a Viva. This is.
Any questions?
No questions. It's okay, no questions, no problems.
Very well articulated.
Thank you, sir. Thank you very much. Thank you.
Thank you, sir. All that I can relate. I was a bit late for the your talk. I think there is a lot more that we have to really pick up from what Ashish has been stressing. I think please remember that word rule of vision. That is very, very important, sir. Rule of vision is very, very important because ultimately we have to chalk out or we have to decide what we want to be first, irrespective of the domain. That's what actually, in fact, I'm very happy to see you saying that actually it is not technology is only a facilitator. That's what I always tell actually. So yesterday was our Android, today is something like that. They are only facilitator. But what will take us and what will make us relevant always is the grasp. That's what I think. So no matter whether you are civil, electrical, electronics, etc. Actually, it is the broad actually the grasp that will have, because as you say that is unless the the domain application specialist to say what to do, all the facilitators will be of no I should say significance actually. So that's so don't be carried always by the technology. Technology is always a facilitator. But how the technology has to be utilized and where you have to take our field is ultimately it is determined by the experts in that field. That's what I can definitely. And we always tell in research, there is a common terminology. Devil is in the details, we say, in a colloquial way. But what is indirectly is depth is in the detail actually. More depth you have, correct now, more detailed you are, and you will be respected actually. I am very thankful to doctors for stressing that actually. So it's ultimately we have to define what we are, and we have to define what we want to be, and again, in a way, late Justice, Supreme Court Justice Ramakrishna used to say, anything that you have, unless you bring the concept of what you call pragmatism and viability, nothing will take up actually. So, irrespective of what others say, you have to listen to them. Ultimately, what is pragmatic, what is viable is what you have to decide, and don't be carried by your landscape. Landscape you have to determine actually. What is available, what is viable for other landscape may not be available, may not be valid for ours. I think very pragmatic and very practical ideas. Dr. Aisha has given, sir. I'm very thankful to you for sharing such a opinion in such a straightforward and frank manner. I'm sure that now we, all of us, irrespective of our age and profession and responsibility, definitely now you have given a lot of insights to think about. Thank you.
Thank you.
I now request Dr. Govinda Kadambi to hand over memento to Mr. Ashish Kushu as a small token of appreciation. Thank you, sir. Let us all break for lunch now. We shall all assemble in the same auditorium around 2:15 p.m. Yeah, thank you.
Next time I'll come. Not at all. Followed by panel. That's always to talk about. No, not at all. I think your talk gave lot of hopes. Thank you so much. Thank you. Pleasure meeting you. Thank you. Not at all. It was a great talk. Another one.
MS Ramaya University of Applied Sciences.
Training and Skill Development Learning Directorate of the University lives on their own.
So this can range from a wide variety of skill-based programs at a very basic level to a very high level of knowledge at a super specialization level.
Candidates with NSQF, that is National Skill Qualification Framework, or regular qualification
Welcome back, everyone. No, wait for 5 more minutes.
Lunch is not over. People are
Welcome back, everyone. I now invite Dr. Govindar Kadambi, Pro Vice Chancellor, RUAS, and Dean FET, to introduce our guest of honor, Dr. A.S. Pillai.
Good afternoon to everyone again. It's my pleasure and privilege to again briefly place before you the extraordinary biographical profile of Dr. Pillai. Definitely it will be inspiration for all of us for the many years and decades to come. Dr. Pillai graduated in electrical engineering from Madras University. He had his management program also at Harvard Business School, and he obtained his PhD from Pune University, and he was awarded DSc from Tumkur University. Dr. Pillai's 4 decades of experience in ISRO and DRDO under the great visionary leaders Dr. Vikram Sarabhai, Professor Satish Dhawan, and Dr. APJ Kalam made him a technology leader in the field of launch vehicles and guided missiles. His contribution to the development of SLV-3 as a core team member and the evolution of PSLV configurations for ISRO have been remarkable. Dr. Pillai's skills in networking multiple institutions for the development of critical missile technologies, overcoming denial regimes enabled the realization of Agni Prithvi Nag Akash missiles under the IGM-DP program as its program director. BrahMos Aerospace is a unique joint venture which is first of its kind between India and Russia to design, develop and produce and market the most advanced supersonic cruise missile. His outstanding leadership qualities made India proud to possess the fastest, highly precise and the most potent missiles, BrahMos, which is now inducted into the Indian Armed Forces. BrahMos is a world leader in the family of cruise missile, surpassing those even in the developed countries. As the founder, CEO and MD of the joint venture, Dr. Pillai is regarded as the father of BrahMos, which has become a role model for establishing joint ventures between the countries. He is also well known as a defense technologist in the world, and Dr. Pillai has been recognized by many prestigious engineering and management institutions with fellowship. He has received honorary doctorates from more than 12 reputed universities, both from India and Russia. The Moscow University of Security Defense Law Enforcement has honored him with the Order of Peter the Great and the Academician of the University. Dr. Pillai has also published very many papers in international, national conferences and journals. Dr. Pillai has written many books including Revolution in Leadership, Nanoscience, Nanotechnology for Engineering. He is the co-author with Dr. Kalam for books entitled Envisioning an Empowered Nation and Thoughts for Change, We Can Do It. He is a recipient of various prestigious awards including Technology Leadership Award, Dr. Vikram Sarabhai Research Award, Organizations for Industrial, Spiritual and Cultural Advancement, International Award from Japan, Raja Ram Mohan Puraskar, Lokmanya Tilak Award, Lal Bahadur Shastri Award, Performance Excellence Award from Institution of Industrial Engineering. Government of India confirmed him the Padma Shri in the year 2002 and Padma Vibhushan in the year 2013. And he also has the distinction of being conferred the Order of the Friendship by the Government of Russian Federation, the highest Russian award for the foreign citizens of highest order. Sir, we are extremely proud and pleased to have your gracious presence, and I request you to deliver the expert. Thank you.
Good afternoon. lunch is really a heavy thing, you know. I hope you got sleep. First slide. First slide. What are we doing? Slide note. So you heard a lot of things about quantum computing and the other AI, all those things. Now I'm going to talk to you about energy. Because if you look at the future, what is going to dominate in the world is clean energy. You know, you need not the conventional fuel, you need the renewable energy. So how do we make ourselves strong? You can remove that MV, there's only MV coming. Okay. So I'll be talking about how to make Earth sustainable. Earth is in danger, you must know that. In another 2 billion years, Earth is going to die. So if Earth is going to die, means due to what? Due to many reasons which I will explain to you. Things are becoming worse every day. We are all contributing to the, to damage the Earth. We are all responsible. I will change. I don't want you. Okay. I will do it. Will it work? Yes. Let me check. It's okay. Okay. So if you look at the technology map of 5,000 years, if you take who dominated in the world in technology, to analyze very carefully, science and technology came from India. All the sciences we talk today have been found out by our people long before. To talk about space research, which we are talking, they have given the plans how to go from one planet to another planet. There are 12 designs available from Bharadwaj. He is talking about planet travels. Atomic energy, all theories of atomic energy is available in our this one 3,000 years before. Cosmology, total understanding of cosmology. Even the sun is at the center, all the planets are going around, was known to the Europeans only later. But we are doing worshipping that sunny temple. When you go, center, the sun is there, all other planets are there. This is there 3,000, 5,000 years. So our knowledge level was very high. And you see, technology wise, if you take, I will show you this pillar. This pillar is in Qutub Minar, Delhi, 3,000 years old, no rust. All metallurgists in the world have come and studied. They are not able to find out. Just a wrought iron and there is no rust. It's just open. Why? So that is the level of technology our people have done. This Panchaloga statue of this one, done by investment casting. But the theory of investment casting is known to the Europeans only recently. But our people are doing years, they are doing. So like that, this is the first alloy of the world. In the Indus Valley, the dancing girl, bronze statue is the first alloy. So like this, there are many examples we can tell. And coming to Karnataka, you see the first rocket was made in Karnataka. World's first rocket was made in Karnataka. What the Chinese did, they made fire arrows using the gunpowder. We got the gunpowder technology and we made it as a rocket. So in the 1792 war against the British, people used 6,000 of these rockets and defeated the British. So that's the history we have. So all these things are okay. All our culture, all our knowledge, everything crashed once the British came. British wanted to see that our culture is not there. That was their aim. They were very successful. They made us to understand. Europeans found out everything. So today we read in our books, Thomas Alva Edison. We read all the fellows whom we are reading. They are all known to us as the inventors. But invention was done much earlier. We don't know about that. Many details are not available. But we are now trying to excavate how much we can find out. Medicine, you take surgery. The surgery, even today, the surgery which is performed, plastic surgery, is the same basis of Sushruta. Aryabhata, Bhaskara, if you see, the theory of gravity was told much before Newton. Newton came only now, 1500 years. Much before our people were talking about the theory of gravity. So many things have been told, not known to us, and still we are slavery mind we are having still. It is not that we have not got the freedom full yet. That's the situation. Now during this time, you have seen the Industrial Revolution, many technologies came and the world moved forward with the many technologies. If you see, these are the technologies, you see that here wise. How then space age came, finally convergent technologies have come now, bio, info, technologies converging now with cognitive science. So all these things are happening, and the society also moved from agriculture to knowledge. And if you, what will dominate in the future, if you see, there are many new things are going to come. One is the speed, we want high speed. So hypersonic is one area where we are working on. We are also working, India also working. So we are looking at the speed of systems. Similarly, human-machine interface is one of the very important things which is going to come. Cyberspace is a very, industry 4.0. The main thing is the cyber-physical systems. All these things are coming up. You are not gone from here. No, I should operate. I don't want you. So what is going to happen is the society is changing. Today morning also we have seen that how the changes come. Chancellor was talking about it. How the society can change? Technology is a tool, we said, but technological innovations, see what you see here, technological innovations can affect the most fundamental changes in the ground rules of economic competitiveness and the environment. Economic competitiveness has created the environment bad, that was. And now we are looking at both together to see how innovation can help to progress, entrepreneurship, solutions, innovations, solutions, then technology utilization leading to competitiveness as well as better environment. Then only it will be sustainable. So the transition today is happening in the technological innovations. So what will happen is we need sustainability means what? We want to get sustained climate, clean air, drinking water, hygiene, green energy, herbs, native medicine, and biodiversity. This is what we want. We want clean earth, we want good life, good environment, and good culture to be remaining. So that's what we want. So what is to be developed is the education, employment, health, then security, which is very important now. Then the population to be stabilized, and the GDP growth. This is what we want. So prosperity index should be high. So this is a plan which we are having to make the earth clean with all the technologies leading to a happy society. So all these things should come and merge. So are we doing that? If you look at the technology map of our country in the last 60 years, you find we have progressed. Morning I talked to you about this, the progress how we have made. We are concentrating on the precision farming, then quantum computing we have come to, and also hydrogen energy, and looking at the new types of chips to be made instead of importing, and we are working on the hypersonic and the new systems which will help us. So our revenue mainly comes from IT and ITS. Last year we got $290 billion we got. So it's a very big help for us. And defense, now export has started in defense. So the $35 billion we are expecting immediately for the defense. And we have conquered the space, one of the leaders in the world for space program. So we have to do many more things in the space in the years to come. Not accurate. So when we are progressing, we see some different situation. So this when we start making our industries, production, all those things, we also spoil the whole thing. Pollution in the air, pollution in water. Bangalore is one typical place where it's a polluted city, Bangalore. Like that, there are many cities in our country, pollution level is more. So how do we do that? Why pollution is more? The carbon dioxide emission is more. And continuously we are emitting. Humans generate 51 billion tons of carbon dioxide every year. We are responsible for that. And we are not interested in reducing whatever we talk, we are not interested in reducing. We have crossed 430 ppm of concentration, which will not allow the temperature to go up. The heat of the surface is dissipated only if it is allowed. This carbon dioxide is not allowing any dissipation. So already 1.5 degree the earth has temperature has increased. So we are expecting nearly 4 degree increase. If 4 degree increase is there, we will not be able to bear the temperature. That is the type of situation it will come. And the earth also over a period of time will look like this. So that is the situation, all dry, rivers will dry. So water will become a very difficult thing. Slowly, another 200 years, the earth will, no water will be there with us. So we need to preserve the trees. One tree absorbs 22 kg of carbon dioxide and releases 20 kg of oxygen. But we are happily cutting the trees. That is the oxygen giver for us. So we need to plant immediately 40 million trees if we want to save the earth quickly. That is the situation. So who is the contributor of this situation? You see that these are the three culprits. So they have made more carbon dioxide produced. India is much less, but it is also substantial now. So we have to see that we don't produce carbon dioxide. So the effect is the ozone depletion, hole over the Antarctica. Ozone depletes over the Antarctica means, what does it mean? The UV radiation is there now on the earth. So the ice is melting, and over a period of time, at least in the 2100, if you see, all coastal cities will be having water. The sea water will enter into the cities. So this is like Chennai. You can see Chennai, people have to go by boat only future. As I said, New York will not be there another 100 years. So this is the type of situation going to come if you don't take action. So we have to reduce the carbon dioxide. So our world has realized that. So net zero is a program which has been put zero emission. So there are people are working different methods by which they can see that net zero comes in. So what is required is the green technology to be used all over. Food production, you have to go for the precision farming is the best method for green technology. Then the climate, reduce the carbon dioxide in the air by not using such fuels. Or if it is not possible, capture the carbon and convert the carbon. So cool the air. Clean energy, biofuel, synthetic natural gas, power through municipal solid waste. All the waste which we are thinking can be made use of to generate power. All technologies are available. Solar, wind, ocean energy, hydrogen, these are the immediate things which we can think of to generate power. Then clean environment, plastic tar road. Where the plastic you don't waste plastic. It can be used for tar road. Then that's the best form of road. Otherwise, every year they do that, because of the corruption. But we can, if you put plastic, it will be good. So it has been found out, and no government wants to take action. Because then they will not get the money. E-waste management, green computing, liquid waste management, all these things to done. Green buildings. This green building, a lot of research has been done. And many designs have come on green buildings. That helps for health. So these are known to you. Solar energy, wind energy, hydrogen energy, fuel, this fuel cell, and ocean energy. I will talk about the ocean little later. So the government has announced 5-point program on how to get into a climate change action. One is 500 gigawatt non-fossil installed energy capacity by 2030. So they want to install 500,000 megawatt power. They want to install using the RE, renewable energy. 50% of the energy, now it is 50% is coal. They want to change over to 50% of energy by green. Then reduce total projected carbon emission by 1 gigaton. Instead of 2.5 is the percent emission, they want to make it 1 gigaton. Reduce carbon intensity of GDP by 45% and by economic terms. Achieve net zero by 2070. This is the government policy which has been announced. So electric vehicles, go for electric vehicles so that pollution is not there. So electric vehicle is coming up in a big way and we have to develop the battery pack for that. So presently we use the lithium ion batteries and the technology is now moving further to the solid state battery. This lithium polymer battery and solid state battery, because lithium batteries when they use scooters are burned automatically. A lot of accidents have happened. So they are now changing over to lithium ion polymer battery as well as they are going for solid state batteries. This is the one. And recovery of this lithium can be recovered. There's one proposal from Pillai University to recover the lithium with the same purity, but that project is still to be approved. And now the sodium has come in a big way from lithium. It is very economical, but it's slightly heavier. ISRO and industrial, they have developed the lithium ion batteries, and this is indigenous technology, not the Chinese technology. What we use mostly today, lithium batteries which are there, they're all using the battery cell from China. But now indigenous things have come and the technology has been given to the industries that has to come in a big way in use. So sodium, my feeling is sodium battery will take over in the course of time. And all these batteries which are generating energy, wind energy, all these things, the problem is that the storage of this energy. So storage, there are new thinkings have come. The best, the SMES, superconducting magnetic energy storage. This is the one which people are now entering into. Then the compressed air energy storage. These are all limited storage for, it will be useful for few kilowatts. But if the energy level is much more and you want to store it for long duration, you have to go to the ocean. Sea water. You can put it in sea water properly in drums which are not getting corroded. You can put that and store the energy. Particularly the green hydrogen, the plan is to go for ocean storage. The solar energy, now we are using the solar cells coming from outside. We don't produce solar cells in India because we don't have the basic material which is required for solar cells. So solar cells are coming from outside, then we use that. These solar cells are inefficient. Now maximum has come as 21%. World over, the solar energy is 21%. A cell can give. But that is not sufficient. And even then the cost is low. We still want to make it better by increasing the efficiency. How do you increase the efficiency of a solar cell? If we are producing solar cell, you have a silicon. Over the silicon, if you assemble carbon nanotubes, vertical, this is called aligned carbon nanotubes over the silica, and if you encapsulate it with a polymer, here it will be 3 OTs put there. So this combination in the laboratory has given 52%. This is not known to Chinese, otherwise immediately they would have done it. India, I am telling for last 5 years, nobody is interested to do that. This is a technology developed by India, outside India. And this technology will help us to increase the efficiency. But then we must, polysilicon we should make. The basic material for the solar cell is polysilicon. We should make polysilicon. We have got a lot of sand available in the country. The countries which don't have cell, they are the sand, they are making polysilicon, but we don't make it. So, but we must make it. Another important technology which has come recently is a thin plastic. If it is dipped with a dye and coated with titanium oxide, it can generate energy. You don't need even solar energy. You can solar cell. You don't need. That is, it's also solar only, but it is not the silicon. It's simple dye, which you see that the light when it falls over the dye, the electrons, it excites electrons. Excited electrons infused into semiconducting titanium oxide. Titanium oxide is a semiconducting material. Very good material. You pour titanium oxide, put your cap, you have music system, you can, have the power. Many people are doing that. Youngsters are doing that. Then the holes, once the holes left the dye molecule, then separation excited by the electrons, the holes create the voltage. The excitement between the electron and the titanium dioxide will make the holes which will generate the voltage. This has been experimentally proved, and it is so cheap. You can generate energy, one unit of energy today is about 2 point something for solar. You can make it for 1 paisa. That is the type of technology which is coming. So another important thing is that decarbonization. So we have to reduce the carbon dioxide emission and also capture it. So there is a method of zero emission power plants. We are most of the power we are generating using thermal power plants. 70% of our power is coming from thermal plants. So these thermal plants are using coal. We are a coal-rich country, but still we import coal from other countries to meet our requirement. This coal, when you have, the carbon dioxide emission happens. So what is the plan is, you let it emit carbon dioxide, you capture the carbon dioxide, and then try to convert the carbon dioxide into methane or other material. That's also possible. Technology is available. So this is to be done. So we don't want sulfur or carbon dioxide or the fly ash to be emitted from the thermal plant. We want to completely control that so that it doesn't emit to the surface. So this technology is also available. Hydrogen. Hydrogen, you have got many types of hydrogen. One is the grey hydrogen. Normal natural gas is used to generate hydrogen, and that emits carbon dioxide out. So that means it is also producing carbon dioxide. It's not good. The blue hydrogen, you same process, but you dump the carbon dioxide inside the earth. So that's also not good. You will be spoiling the earth further. So that's why this green hydrogen came. Green hydrogen means the green energy produced through wind or solar is used to desalinate the water or split the water, H2 and O2, H2 and O. O2 is taken out and the hydrogen is used. This is the process of electrolysis by splitting the water. So this is there. But this process, when many countries have tried to use, but the hydrogen is $2 per kilogram, which we cannot afford. So there's a new concept is coming out, how to make hydrogen cheaper. So many people are working on that. Hydrogen is a very important material for the future. So from hydrogen you can produce, the waste hydrogen you can produce ammonia. So 55% of the hydrogen can be used for that. And petroleum refining, all these things can be done. The hydrogen is going to be a very, very important, particularly for all aviation, everything hydrogen will come. The future aircraft will be flown by hydrogen. And everything hydrogen is going to come. People have tried out. Iceland is, the whole Iceland is only on hydrogen. There's no fuel there, it's a hydrogen fuel only they use. So hydrogen is a very important material and the energy level is very high compared to all other things. But compared to solar and all, the energy level is very high. So, but cost is high, that's why the whole thing is getting into more research. and people are trying to use a combination. See this solar, wind power is generated that goes to the grid, and that's also used to generate the hydrogen, which is going to be used for multiple purposes. So the government has announced the hydrogen mission. So hydrogen mission means they are pumping 19,744 crore has been announced by Prime Minister for hydrogen, green hydrogen. So this work is going to be done, and there are pilot projects have been launched. There are many valleys are coming. A valley in Kerala coming in Palkad. Then Maharashtra they are going to do it in Pune. Like that, each state has got their own plans to use this fund. So the infrastructure, hydrogen hubs, how to use hydrogen, the codes, and how to use the hydrogen energy in the grid. All plans are being worked out, and the plans are being generated, policies are being evolved, and this is under the mission. This is a very important thing. Huge money is going to be spent on the hydrogen energy. Now, if you look at the ocean, it's very, very interesting. We are not using the ocean. Ocean has got tides, ocean has got waves, ocean currents are there, and there's a thermal difference in the ocean. Top surface is temperature is high, will go down and very cool like that. So the difference in temperature can be used for producing electricity and the thermal energy. Tide can be used for energy. All these things are possible. People have tried out tidal and wave. Some experiments have been done, but nothing much is being done. So they have done for study purpose. But there are a lot of opportunities other countries have taken up. And the ocean current, some of the places current, inside there's a current in the ocean. So that can be used for the flow, can be used for generating power. And the most attractive thing is the temperature difference. This can produce large energy. You see, ocean, it absorbs energy equivalent to 250 billion barrels of oil every day. One day, ocean, see, it's a big ocean. 71% of the earth is the ocean. So it collects all the energy from the sun. And see, 250 billion barrels of oil equivalent is absorbed every day. So this is the one thing which we cannot ignore. We really want renewable energy. And another important thing which people don't know is uranium is available in the seawater. We are going to different countries for uranium. We don't have uranium. So we go there to supply group, nuclear supply group, it's called. We go there. But here, this energy, the uranium is renewable. Uranium, you take out uranium, again uranium comes now out of the ocean. So for 100,000 years, you can generate 100 megawatt of power and 1,000 stations you can have. So that much quantity of uranium is just lying there. Nobody is using. No country is using. Because the other countries, they have no use. But we need uranium. So we should deploy the uranium, which will be a very big asset for us. Well, we have to operate all our stations, nuclear stations, power stations. We don't have the uranium today. Now there's one new concept has come. How to use my so ocean thermal energy, how do you do that? It's a new concept is you go to the ocean, have a hexagonal station, a large station. This phenomenon is called VOTEC. VOTEC is ocean thermal energy conversion. So you can use the temperature difference and generate the power. That's a clean power. You can also put offshore windmills. The current energy, the wind is much better in the ocean. If you go to the ocean, the wind is better. So your wind energy production will be higher. You can put solar panels there, it's open. You can put solar panels. So if you have a place like this, open place, you can generate a huge energy you can generate. This huge energy can be used for converting the ocean water to drinking water. Like what Israel is doing, convert the ocean water into good water and for the irrigation as well as for drinking, everything they are using. Singapore is using. And Singapore does not have any river. they are using. So this is one thing which is going to help us on a long-term basis to get water, get energy, all those things. So the another thing is the hydrogen storage. Hydrogen cylinders, I told you, storage problem. Best storage is here. In order to go out, you can store the energy which we are saying, energy storage, the best place to store energy source. So we can have have the pits and put that there. The portion is available to you to keep the energy for a long time. So this is one thing. Another thing help which can give is you are having a solar power satellite. You need the energy which is generated electrical energy. It's a DC. That energy is converted into microwave, and then microwave is passed on to a place which is to be remote. You cannot pass it on in city. So remote place, this type of thing is there. It is a remote place where you can do it and convert it into the AC current and then deploy it to our people. So that is another application of this motion. One more energy is coming, is called fusion energy. What we are using uranium is split energy, that is fission. So fusion energy is going to be very, very important when the radiation level will be different. So there is a program now going on to master the fusion energy with 500 megawatt reactor by 2025, and 7 nations have joined together: India, China, USA, South Korea, Russia, Europe, all these countries, and it is being built in France, and this reactor. And then our contribution is the huge monster cryostat has been built by us. And 600 of our people are working in this to realize this at France. And all the vacuum vessels are made in Bangalore and have been transported there. The program is a very huge program, and countries are cooperating. The idea is by 2025, once it goes to critical, then we will be having the complete technology of fusion energy. So fusion energy is important. Why it is important? We are going for the moon mission. Soon our Indians will land on the moon, and will be going to have a factory on the moon in another 10-15 years. Once the factory is there, you want to mine the helium-3 material from there, bottle it, and bring it back using a launch pad there. This launch pad in the moon is very easy, where the gravity is 1/6. So we can have a higher payload efficiency we can have. So small rocket can bring more thing, it will be dumped into orbit, and from orbit another system will collect it and bring it to the Earth, and we will be using it for generating energy. This will be the most efficient energy without any radiation. So this is the future. 2040 we'll be having helium-3 as the energy source for that. And the Americans are going to have their stay on their moon in 2026. Already one mission, Artemis, they have done. Artemis is called. So second one is going this month. So they are going to have a series of plans to see that they settle down on the moon in 2026. And China and Russia, knowing the American program, they have joined together. They are having plan to reach there by 2029. So you will see 2030 moon will be occupied by people, and factories will come. They will start digging out all exotic materials what is available. Why exotic materials has come on the moon? Why not on the Earth? So Earth is occupied. Earth is the whole system is different. Moon is just a barren, and all solar radiations it has absorbed. So it has got the energy it received. So all energies are now available in different types of different forms. And asteroids are there. Asteroids are very good. You want radiant material, you can get from asteroids. So all these things are there. There's one asteroid only full of diamonds. Very huge diamond asteroid we have got. So like that, there are very interesting things are there in the space. We were earlier traveling on the sea to bring wealth for our country. Now we have to go to space for bringing wealth. So another thing is the satellite, solar power satellite, which I told you, you get 24 hours power there. You put on the Earth, you get only maximum 6 hours only you get. So here you can get a power and you can get it. I told you that. So what is the path to energy security if you want to be secure for energy, which is a very important requirement? One is solar power technology with increased efficiency, decarbonization, carbon capture and carbon green coal solutions. Then large scale grid integration of renewable energy so that energy is not stored immediately given to the grid. Develop energy storage solutions for enhanced reliability. Then invest in green technology, hydrogen, which government has now done that. Then tap ocean thermal energy and uranium. Helium-3 from the moon, that is long term, for fusion power and solar power satellite. It's a long term, I am giving a plan for long term. So in the next 100 years we should be having energy sufficient country. So in this, many new technologies have come, as we call it Industry 4.0. All these technologies, which is morning we talked some of them, big data, AI, robotics, augmented reality, 3D printing, which is called additive manufacturing, cyber security, blockchain, IoT, and then system integration, simulation, all these things. They are increasing the efficiency and productivity. Cyber physical systems, that's the word. Industry 1.0. 2.0, electric energy came in a big way, and assembly lines. Third is automation, computers, electronics. Now it is cyber physical systems. What is the future of that? Is Industry 5.0. What is 5.0? It is a sustainable, human-centric and resilient industry. Today, the industry, because what I told you, that you have to save the earth. You have to save the earth with all the new technologies, it's not saving the earth. So you have to convert these technologies to suitable to the earth. That means you have to green solutions have to come. All these things are combined in the Industry 5.0. So next 100 years, if you look at the next 100 years for you, aerospace is going to be dominant. So it is going to be very interesting future in there, and the energy is one of the very, very critical things for the future. So that is what we thought I would convey to you. So thank you very much. If you want to ask any questions, please ask.
If anybody has any questions.
So very nice presentation, and it is really interesting to see that so much has already been innovated, the OTEC and other things which you said. So that must have been very costly, so much of investment into research and all. What about the application, what about the commercialization and use? What are the, in your opinion, what are the hindrances? Why isn't it being implemented if it's already there?
See, we normally, when you think of some application, first thing is the technology is proved. Then there's different levels, TRL, you know about TRL, different levels it is there. You develop the technology, and then when you want to scale up, so you need the investment. When you look at the investment, you analyze whether the investment will lead to a profitable game or not. If it is not profitable, then you may drop. If it's absolute necessity, then you do it. Okay. Now we are talking about the necessity. You want a green earth, you want. So that is a necessity. So what are the different ways you can generate power? If we talk about solar energy, today solar energy is very good. People are very happy with that. But how long China will give you that solar cells? So we have to make the solar cell. Investment will come. So you cannot be worried. Why India is not able to make the chips today? Okay. Because investment is high. So we thought that investment is high, we will only buy. Today people are not going to give, the military components are required for our program. We are not able to get. We are now getting the industry level components, industry grade, and then qualifying it for military is a very wrong method we are using. We are not able to get military components because the SCL which is there, which is supposed to support us, there are 2-3 factories are there, they are not able to reach to the level which we want, technology level. That means you need investment. So Why a country like Taiwan is putting a big investment and doing business with their export? So our culture is wrong. You think that everything we are making is for our use. No. You should have a plan like Israel. Israel, if a factory to be approved, they say 80% you should export. Here we should take the stick we have to take. Any factory if you put, factory should be good factory, that is, it should follow the norms. Second, it should export. That our stick is not there. A country which is which is which has got corrupt inside society, corrupt election system, corrupt politicians will never like to invest because investment is huge and technology is huge. We are all worried about how much money we'll get out of that and how much technology we can give to the people. That we don't see. That is our problem. It is not, the investment is not at all an issue. A solar power satellite is easy to put for us. That will give a better energy than the solar cells. But there also you need some cells you need. We are using solar cells in all our satellites. They are all important. We don't make here. So we should also invest on critical facilities which we think that it is going to be a sustained. No country will help us. It's like MTCR, Missile Technology Control Regime they imposed. Like the today situation, because we are a neutral country in the war, we are supported by both. But tomorrow if the political system changes and you take a side, other the people will not support us. So why should we do? So far in our history after independence, we have not got any support from USA. The only negative, they would have wanted to kill our development. Whereas Russia helped us all the time. So that is the situation today. Now we are taking, because we are taking neutral stand, they are coming forward. Yesterday the defense minister of US was there. He said we want technology cooperation. I have gone there and talked technology cooperation in Pentagon many times. They all say yes, yes, but they don't do anything. Whereas I have also gone to Russia many times. Anything you want, you take this. That's the difference. So the point is, what your question is a very valid question. Investment is very important. That is why 19,000 crore when the Prime Minister announced for hydrogen, it is only for investments. They want the investment to happen.
To a layperson, 19,400 crores sounds like a big investment that they are willing to make in hydrogen. And such things won't come from private parties. This has to be government driven, basically.
Our private people are very rich people are there. What Mukesh Ambani is doing with billions of dollars with him? We are proud to say we are having so many billions, billion level people, 10 people or $1 billion people are saying, what are they doing? They should invest. If they are interested in the country, they should do country program. What Ratan Tata is doing, all business only is doing. From jewelry to all these things, everything is business. Is that the type of people you want? You want people to think and then invest in facilities, invest in the infrastructure to support the people. That's what it is. Technology can be developed, but it has to come from the people. Government, how long government can support? All other countries, private investment has happened. Except in the USA, there is a DARPA program and they support the research. But investment is done by the companies only.
After technology is proven.
Yes. They evaluate the technology and then they do it, yes. That's why the TRL matters. All the universities must develop technologies up to TRL 3. And we must work with the industry. Now, there is a fund called Technology Development Fund. It is given by DST as well as DRDO. You can have any crores you can have, provided you are aligning with one industry after developing TRL 3. If you have got a TRL 3 technology, you join with the industry, jointly you give a proposal for making it to TRL 6 for production, and they give fund for you. There are schemes are there, we don't use it. Most of the money, our money is going waste. Finally, it is going to some black money people only. Political people only. They are not some scheme, the scheme is not done. Where is the money? expenditure is over. They are having a very bad system of leaders. That's a problem. Good leaders is, Gandhi said, even 1 paisa I have to account, he said. Here, you don't account 1 paisa, you account 1 crore. That's also not there. Okay. So anyhow, I think it is our last slide. One more slide is there. Okay, so as I am concluding like that, I told you about the prosperity of our nation 2000 years before. All things have come, scientific thoughts, everything has come from our country, all big things, and moreover, civilization is very higher level civilization in the only country to the world. But we dropped ourselves because of the invasion, non-participation in industrial revolution, and population growth. We came to make India a red India, and then we slowly started doing. The thrust came from the globalization in 91, then thrust for industry growth, information age helped us, all our youngsters got job. Then now we are in the knowledge age, technology and innovation only will take us further to different heights, and we have got the best resource, 800 billion youth got. So GDP will increase, and our industry should make for the world. Make in India I don't want, make for the world. So if you can make things for the world, then our prosperity will come. So future is India, as I see. Only country which can be there. China, prosperity is good, but it will now diminish because of the population problem. Their population is less than our population. We have taken our number one position. But that number one is not important, this number one is important. 800 million youth. So youth can transform India a global leader to save the earth. So green India we want. Thank you. Any other question? Yes, please.
This is regarding to electric vehicles, at least in the European countries where they are not dependent on solar energy and all. So they use at least coal as thermal and all these things. So there also emission will be more. Being an electrical engineer, yeah, we have to opt for electric vehicles. So, but there is a general trend in the market saying that electric vehicles is just the bridge between these, normal vehicles and the hydrogen vehicles.
That is only in India.
Yeah.
Their electric vehicles are normally used. You go like our station for petrol, and the recharging place of main 20. Every 1 kilometer there is a recharging facility. If you go to Germany, it's like that. So Europeans have conquered. Europeans have reduced the carbon dioxide production substantially. There is one country which has reduced 95%. The Scandinavian country is leading today. America is not leading. Scandinavian country is leading. So Europe is having a good program on the this one, and they are also not getting fuel from Russia and also from. Sir?
Sir, I'm an entrepreneur.
Okay.
So this is not a question, just a suggestion, to each let's say people who you can the word of us. So you spoke of technology development from both the DRDO as well as ASD. The DRDO we had explored. The only one constraint right now what we face there is regarding little bit relaxed now because of bank guarantee. So what happens is for small entities it becomes difficult to get the bank also convinced on technology. The bank guarantee part has to be addressed. If that gets addressed, then we will certainly be able to do that. Just a suggestion.
See, government money when they want to give, there should be a guarantee for that. Otherwise, their rate will be chopped.
Yeah, little relaxation.
Yeah, how do they relax for a man whom they don't know? If at an organization, you get a link with another organization, government organization.
We do ask for that suggestion, sir.
No, suggestion I can give you. Suppose another DRDO lab in Bangalore, you are a Bangalore person, and there are a number of labs in Bangalore, you collaborate with them and make a joint proposal and send to DRDO, they will give. Because that guarantee is there, there is another institution is working with you.
That is correct, sir. I mean, institution is there, but bank also asks certain questions.
No. That is bank guarantee procedure is a standard procedure. If you are a small entrepreneur, you don't have money to deposit in the bank. So you will have a problem to get bank guarantee. Without bank guarantee, government money cannot be given to you because they don't know you.
Exactly.
Suppose you vanish tomorrow,
that becomes
you take a passport and go to Sri Lanka, they will not find out.
That becomes the hindrance, sir. Like, because,
That will be there. That's why I am giving a route to you. You align yourself with a good industry or a good lab, R&D lab, then they will believe you.
Right. Better.
Okay? Yes.
I just want to ask you this: how much percentage do you think that we should, bring up the
We should spend on
the industrial sector so that we have a much better aspect of gross domestic product?
See, first initially you don't have to depend on the industry. Initially the basic development, research and development is done by the institution or R&D lab. So you reach certain level. That's what I said, TRL3 level. Then only it will be visible. Then when you discuss with the industry, you have to see how much you can part with him or how much they can part with you. Today industries are in a position to support your research also. So your cooperation with the research, the industry is very important. There is no such percentage. It depends on the product, depends on the market situation. Everything they will analyze before deciding. Okay. Thank you. Thank you very much.
Anush, are you there? Anush, okay.
Don't give any moment, I'll receive.
Yes.
And the Printlytics, we'll just give that to
Thank you for enlightening us with your words, sir. We now move on to the next event. First, let me all this. I now invite the RTBI Incubatees, MVega Technologies, and Printlytics to deliver the technical presentation.
So, it's really close.
Okay, good afternoon everyone. Myself Anush, I'm the founder of MVega Technologies. This is MVega Technologies. Next. About us, actually we are the alumni of ROAS only. And I'm the founder and director our team is like a multidisciplinary team. We have engineers, designers, and product developers. It's like a different team. In the engineer segment, we have mechanical, electronics, electrical, and the machine learning people, everyone in a single team. And recently we joined a designer teams from product design team for the ROAS. And our main aim is to make a indigenous electric vehicles for the people. We are making a 95% of materials made in India, including like we are making a motor, controller, and converters in-house in the RDBA itself. And we are not only focusing on the electric vehicles, we have ESDM sector also, and IoT robotics and predictive algorithms. So we will go through that later. It's like all are like a small sectors. We have been done 11 products, and we have 5 satisfied clients, and we have only 14 team peoples currently. This is our core team, myself Anush, and co-founder is Shweta Yasuli. And these all are, everyone is from ROAS alumni only. And we have technical interns from 5 members and design interns for 4 members. So our company mission is bringing innovations to solve the problem and making technical products for global market needs. And our vision is enhancement of technology for the better world. So the company aim is started, like for example, we have been started at 2020, not 2021, it's like actually registered or established at 2021, but we have started like during 2018 only, during our MTech. So we have been developed our first motor in the college during a MTech project as a BLDC hub motor, and we have been successfully completed and we have tested that. After that only we got a confidence to make a company. And in that things we have been done here, and I came here. Next thing. So this is our small achievements. This 2021 we have been registered to the NCA as a registered company, and we got a funding from Startup India and also Startup Karnataka during the 2021. And during 2022 we have been have product design and development team. We have been made like you know about the startups. We'll be having a piece of people, like 1 or 2 people having design thinking and some people having product development thinking, or they're having a different thoughts. So in that, we have made a stable product design and development team in the 2022. And we have been collaborated with the Airdays Private Limited. These people are making a drones. It's like a people going to travel in the next future, right? In the drone technologies. That kind of drones they are making. For them, we have been collaborated to make the motors and design and develop some of the crucial projects for the electric vehicles. We have been made in-house products like motor, controller, and converters. And we have been participating in BTS 2022, and we have bike model prototype. We have been tested actually. We have been tested a bike model, and that is like a complete functionalities. It is not a complete bike. It is a functionalities only we tested. And in 2023, we have been participating in MSME Expo. MSME Expo is done in our ROAS only. And we have been collaborating with UCOM Private Limited, which is nearby here only, our campus. That fellows is going to give some industry projects to us, and they are also collaborated with us to make some R&D projects. And we have been started on small project, defense project. It is it will be a small controller for a small robot. And we have been conducted a design competition in Aoki in the ROAS only. This is a different thing. I will just show you that Aoki thing. And this is a collaborated with COE Aerospace VTU for product development. We have been making products with like patented things, and we are making with the certified softwares. So this is some electric vehicle segment. So we have been made in-house motor, that's the magnets actually. We have been made everything, we have been assembled all the magnets and complete materials in the Ramaya only. And this is one of the development board samples, and these two are the IoT modules. And this is a motor development activities. This is a software side. We are making the motors, and this is a hardware segment. So where we have made the stampings and windings, everything in the in-house. And this is a small image of that thing. It's like we have been completed that windings, and this is a battery pack, and we have been assembled that motor into the bike there. And this is a sample test for the bike. We have been assembled to this bike model. It's like a Victor or something like Bajaj vehicle. We have been assembled that to this bike, and we have been run that one. It is working fine, and still now it is working from 2018. This is the first model we have made in a Ramya college, and still now it is working. And this is a development board. It is for the students, electronic students, electrical students is there. They want to learn some electronics gadgets means they can go for it. It's like a 14 types of projects they can make it in a single board. That's the things we have been, that's the thing we have kept in this board. And that is the controller which is used for the motor drives. Like you know about electric vehicles. Electric vehicles will run through the DC motors. It will not going to run as a normal DC motor. It will be having some controllers. That is that controller. And that is the projects we are supporting. Now recently we are joined with the normal sensor modules. So for the DUCOM projects. So that is the one modules. Yeah, this is Anoki's like we got from the, we have been conducted a normal, like we have been stopped at the normal interviews. We have been started the strategic interviews. So by conducting a competition to like an Anoki Fest, we have been done, it's like a small amount of prizes also for them, and we got a very best people from the design team, and we have like 4 to 5 people in the design segment. So they only made these all designs, and we are going to bring the designs from these college students who are the interns, they are working actually. And I am training for them, I am just giving a small trainings, I am not giving a full complete training. Whatever I just want, I am making them to make this product. Actually this model is also from that fellows only. These are like, this is not our final model. This is all just the models from the interns. Yeah, currently we are making a 3D printer. It's like 1.5 meter cross 1 meter cross 1 meter size. We can print. And it is completely in-house made. We only making the 3D printer. This is a one present thing we are just making. Now next, whatever is going to come as a by parts, we are going to print in a single stretch in this printer. And these are our clients like UCOM and DRDO. And we got support from Startup India, Startup Karnataka, and Make a Village, and VQ. And I have to say, the thing like Ramaya, GOP, RTPL. And thank you. Any questions? Yeah, actually, we are planning on next 4 months. We are going to come from just plastic parts and this body case, everything is ready. We are going to complete that. Yes. It's completely made in Nigeria.
What are the major challenges you faced as part of the journey and what keeps you?
Major challenges is like getting funding, first thing. So once the funding came, then it is happened with our, so we know about like we will make some products in the technical aspects. We will be running, we are bringing some components and we will connect it and we will run that. Unfortunately it will work, but it is not going to work as a product, right? So to make that, we have to make several tests. That time we got a very crucial problems. By doing the testing and these all things, we got a very big problems and we burned some boards and we lost like nearly 30 to 40,000 rupees for single module. So like that. So that's the one small thing we are facing. But apart from that, whatever we are going to plan for the next things, we are not making any kind of hold for that. Whatever we are planning, we are executing that. It's like it may take some delay because of some external parameters, but we are not going to stopping that. We are moving towards that.
Congratulations, Arush. This looks very good. Are
Thank
you
you.
doing this full time?
Yes, sir?
Are you doing this full time? Like
No, ma'am.
completely?
I'm just doing a half time only.
Okay, but it looks like good progress. So I was just curious, you mentioned about the printer. You're doing your own printer, or there's
Yes,
already
it is our own printer.
But there's already a RTBA.
The size is not sufficient for making the printer.
Okay, you will
That's
not
the part. Yeah. The size is not sufficient. That's it.
And so when you're working on this, I mean, obviously you would want this to be a commercial thing and
Yes.
go to market with it. How do you find this to be different from the Ola scooters and other things?
So actually, you guys know about that news everything. We have been like FAME 2 subsidies. So they have been, that subsidy is only for making the Make in India products. It's not for assembling the Indian economies, assembling the products from different countries. So that people are to capture the market, they have been bringing that all parts from the other countries. And they just assemble that in India and they are selling it to the Indians. So that is not a way actually to sell the product. That's why that FAME 2 organization is already put a case on them to return back the money. So now we are making these completely like, apart from battery packs, like battery cells, including battery packs we are only making. So apart from battery cells, completely we are making in India. Maybe we may ask for the concession for some other percentage like 5% or 10% as a concession for the subsidies. So later we can go for the complete subsidies we are going to give for our customers. That's the one strategy we have.
Okay, so Ola, you mean to say they are simply assembling because they made a big hue and cry about a huge manufacturing plant that
Everything is assembly. It's assembly. It's UK project. It's a UK product actually.
Because I just followed up to the time they were setting up the plant and it was a very big news that it's...
Yes, ma'am. You just see about like when they started and when they launched the product. You can get to know about that one. A small product is going to take longer time to make testing and everything. Immediately how they can come to the market. You just check it out.
Yeah. Ola, what is the assembly plant, whatever they have, is for mechanical part assemblies.
Yes.
It is not for the internal battery and other things. But they are still doing the battery line assemblies, everything.
The battery,
they have started with one plant
Tamil Nadu.
where they are starting up with battery manufacturing.
Battery manufacturing plant.
Yeah.
And even I think Bajaj started to venture in this space.
Yes.
Right?
Bajaj also started that. Yes.
So you are in a very, very tough space. So what we suggest is you will have to look at how you can make it as a commercial venture when you take it up towards production. See, for R&D you have got a lot of funding and you are able to achieve this particular level. But once you take it to the commercial level, I think you will have to have a very strong business plan and the funding.
That is completely depend upon strategies, man. We have to plan some strategies because now unexpectedly it came like different companies came. It's not like a one company, means Ola and Ether is not a competitor. It's like came like 150 companies, now it is a competitor for me.
Yes.
So we have to fight with them. Is there is a different strategies is required. It's not like a normal bikes we have to release. So we have that, and this event we are going to release that bikes.
All the best.
How about RI certification? Have you opposed?
No, we are not done. We have to do.
How about?
It's just like a functionality test is completed, like motor, controller, converter, these all things. We have to go for the ARI test.
Should be big protocol.
Yes.
So you initiate prototype.
Yeah.
But you can approach during prototype stage only.
Yes, it is a prototype.
Okay. And then how about the hub motor production? The winding.
We are only making it.
In-house.
Yes.
Winding process.
Winding process we are doing outside.
Okay, outside.
Okay.
India only or?
India only, nearby.
Yeah. You can have to make any customized.
Yes.
Thank you.
Okay, thank you. Yes, sir. Actually, in fact, out of 4 or 5 graduated actually, that Anush has been one of the proud incubators actually. In the second year itself, we got that elevator, Karnataka elevator funding of about 18 lakhs. And he has not told some of the novelties of his design. But whatever little I know, I can tell actually. That is, they have applied for a patent of hybrid controller. That means where the controller is able to switch whether the rider is asking for an improvement in the torque or whether he is going for the increase in the speed actually. So that the hybrid controller is what one of the things actually. And we are very proud actually of Anush and of course our other partners, Shweta Buli. They're all our alumni actually. And I think appreciate it's not a software project. I'm not denigrating software project, but hardware project in the initial itself it has to go through a lot of difficulties actually. We are proud that Anush and Shweta and the team, they have really gone through it and they have made a rapid progress. Okay, we wish all the best, and our RTBI and our UNICEF support will always be with you.
Sure, sir. Thank you. So all our aim for the interns as to our company, and everyone is settled in hardware company. That is one of the satisfaction I have. So a lot of people who are graduated in ROAS as the electronics people also, they are just moving to the software segment. But my interns is going for the hardware segment as a hardware engineers. That's my happiness.
Exactly.
Giving back to the institution actually. That he has been very, very generous, and actually, he's also one of the proud sponsors for this program. Actually, thank you very much. Okay. Distribute. Sure.
Very good afternoon, everyone. I'm Kiran, founder of Pillai Private Limited. So I'm going to take you through a short journey and also talk a little bit about what we are doing as incubators at RTBI. So we've been at RTBI since January this year, but the company has been there since 2018. To begin with, I'll tell you a little bit about my background. So I'm a mechanical engineer. Happen to work for companies like Saint Gobain, Bosch, and there is also Musicma Analytics. Used to be a very successful startup, based out of Bangalore. So I worked there, and then along with my co-founder Dr. Abhishek is how I started Pillai. So at Pillai, we are trying to be different, be innovative, and try and then help companies like Emrega and a lot of others to make sure they become successful in their manufacturing journey while making products out of India. So in that sense, we are trying to build a platform for mechanical, electronics, and also utilizing sustainable materials. Given like in the previous context, our guest also enlightened you all about sustainability aspect and its importance. So putting all of these things together, we're trying to build a platform. So next slide. So yeah, Dr. Abhishek, he's done his PhD in physics, and material science, has been his area of work previously. So he's my co-founder in the company. We also have Mr. Ramandeep Singh, who is an investor in the company, being himself an environmentalist and a serial entrepreneur earlier. So he's also helping us in strategy and so on and so forth. So we also have several advisors on board who have run their own industries previously. Just to name a few, like Mr. Narendra Narayan is founder MD at Vinyas Innovative Technologies, Mysore. It's one of the largest leading EMS manufacturing house in India. So what is the problem that which we are trying to solve for or address is, you all are aware, right? Pictures speak a million words. So in that sense, there exists a large technology gap when we sort of look at OEMs, largely developed countries OEMs, some in India, who have made leap in technology for manufacturing processes, considering Industry 4.0, digitization, and various different things. But if we sort of look at our supply chain, almost 80% of industries in India, if we sort of propagate it to the shop floor, it pretty much sort of looks like that. The reason is because these are still not yet digitized, and the process of the supply chain is still at a certain stage. And this brings about the gaps in identifying whether there are the right machineries in place, right processes in place, right practices in place, and so on and so forth in an order to delivery cycle. So can we deliver some things as fast as like a Swiggy or a Zomato, right, in manufacturing, which is still not the case yet, right? So and in that sense, that's a huge gap which exists while developed countries are catching up, and why not India? So in that sense, we're trying to address this gap. So we're trying to build a solution which should ideally go global, since it's a digital platform, which should help in faster production, help say for making products more affordable and bring about the necessary quality check and steps and processes in a product getting manufactured out of India. So next slide. So we call that our MMI.ai platform, which in a nutshell, like I spoke about it in the introduction, that comprises say for mechanical, electronics, and sustainable and eco-friendly products. So on the sustainable eco-friendly products, the genesis is typically when a physical product starts with raw material. So we have been successful to have done a few work in terms of utilizing rice husk, coffee husk, wheat husk materials, and have made some products, and some are there also on the table, which you can probably pass around, and you can take a look at it. So the platform typically comprises from design stage to the product which is at a prototype stage to then putting it across for production. So in a sense saying that why only Ola should get into say diversification, or why only say someone else should get into it, why not Mvega become successful? So we want to make smaller companies who can come up with a lot of innovative products also be able to compete and flourish. So that's the area what we're trying to address. The next slide. So this is like a quick gallery. So in the last journey of about 5 years, which we completed about 2 days ago. So we worked across almost close to 1,000 orders, different variety of products, baskets of products from drones to EVs to healthcare and so on and so forth, to fully understand the outlay of what goes into making products and what are the different challenges in one senses while we are manufacturing things in India. What are the technology gaps, what are the process gaps, and how you can say benefit on top of it. So in that sense, mechanical has been a strong area. Electronics we have recently got into, given the backing of our advisors, and on sustainable products also we have worked on products. Next slide. So this is like a successful case study. Now, say for a small company or a startup like us, why does a large company like Jio need us, right? So in that sense, the ability to deliver something as fast as Swiggy or Zomato, right, is the need of the hour. So Jio was struggling to get some of their devices, prototype with the right color, right combination, and 3D print and things like that. So RTY has been helpful for us in that sense, where we utilize the ecosystem also. So and we were able to actually give them a quick service delivery, say for what exactly they were looking forward to in about 48 as less as 48 hours. And that actually helped us to now start working with them in different engagements for larger volumes of manufacturing. Next slide. So this is like a quick traction slide. So we have a host of customers, and we've done a lot of different kinds of projects. I'm happy to take questions. Next slide. So our segment focus is critically on 4 category of nature of product categories, or companies who make these kind of products, which are into automotive and EVs, drones, robotics and IoT devices, and medical device segment. Next slide. So I have some pictures to just share that various different numerous kinds of things what we do. So you've seen all of these are like 3D printed battery chargers, charging stations, for EVs, which keeps happening. I'm limited to share the pictures here. That I can't bring out all the orders what we've done, but whatever I can sort of showcase. So you name the designs, that sort of can be done in 3D printing. So when it comes to sort of 3D printing, we are a pure services company. Unlike other companies who make machineries, we don't make machineries, but we provide pure services. So in that sense, we offer 6 different 3D printing categories of technologies with which various different kinds of products can be made. Next slide. So this is on the UAV and drones. So as on the picture, you may not be able to see the dimensions, but the wingspan is almost close to 2 meters, and the fuselage of the drone is almost close to say about close to a meter in length. So all of this is like 3D printed in single pieces, and have sort of been worked around. Next slide. These are all carbon fiber components. Some of the other components where we use vacuum casting, alternatively for low batch volume production instead of injection molding, and we work on that. Next slide. So on the IoT side, we worked on various different kinds of things. So this is like an IoT device. On the bottom side, where you can see a little bit in chrome and a little bit in yellowish color. So that's a specialized coating. So it's a metal enclosure which was made for an IoT device which was going into an Indian Army tank. So this is like on the medical side. So we worked on simulators. We've been 3D printing a lot of components, and we've built an entire unit. On the right hand side, what you see a vertical structure. That's like India's first dialysis machine for liver. So thank you so much. Next slide. Next slide. Next slide. Yes. So we were fortunate that with the support of one of our board of advisors, we recently signed an MOU with the ePlane company. So we were also in the press. Next slide, please. So yeah, we also had a small press release, and a little bit of information about this. So yeah, thank you so much.
Any questions?
See, what I understood from your presentation, you're mostly into 3D printing services. Like what is the kind of value you're bringing into the industry in terms of, I can say, design, manufacturing and production, where you said
so 3D printing was something which we started with, madam. But right now we offer, one of the slides which I have not put out is, we offer 13 plus manufacturing technologies right now. Plus back it up by say about 45 plus post-processing methods. So that what happens is say any product that which needs to be made can be sort of fixed into a certain template, saying that you put your designs here. This is how say this gets manufactured. This is how it gets post-processed. This is how it gets packed, and then so you can directly ship it across. So in a sense, saying that every whether it's a startup or a small company, especially. Do not have large volumes of requirements. They have smaller batch volume of requirements. So for which what gets addressed at a certain price point has to be templatized. That is something which a lot of Indian companies or startups actually do not have, and they go through that cycle of working with multiple different suppliers, and that takes away a lot of time. So you templatize that, put it on a platform, helps you to get things going much faster. And we want to try and replicate this. Like India industrial area is a strong hub for us. We want to replicate this across other industrial area hubs, starting with Mysore, which is where we have already started, to then, looking at Hubli, Dharwad, Belgaum belt also as a hub, so that, we are able to make sure that we're getting the right product, right output, just like say how you order, say, what you would want on a Swiggy or Zomato.
It's a food grade.
Yeah.
Grade.
Yeah, you can see the samples.
Which material?
So there are three different categories over here. One is, these are of rice husk, these are made out of coffee husk. This is a coffee mug made out of coffee husk.
So 3D printed one, no?
Not 3D printed, this is injection molded. So okay. The innovation is on the raw material side.
See, it's ready to use.
Yeah, that is ready.
No other any other polishing or anything needed.
Not required, sir. So there is food safety certificates are from TUV for BPA free dishwasher safe, and the details are there.
Fine. So if anything to be like shape changing or anything, you need to prepare mold and you need to do it, right?
Correct. Yes. So the technology where we have freeze for this material to work is typically on.
Okay. So you said it's injection molding.
Injection.
Do you have the facility for injection molding?
We have our machine shop, and for molding, so we have two partners in India who we have collaborated.
Fine, thank you.
So it is mostly a sourcing aggregation model is what.
It's a hybrid method. So we have made our investments into our own 3D printers also over the period of time. Whatever orders we did, all of that we have invested on, especially additive manufacturing, which is 3D printing, which is our own. To then adding, say, the sourcing capabilities of wherever conventional manufacturing process is there. So we have two VMCs of our own, because we do tooling of our own, tooling design of our own. So we invested in that also. What happens is, you operate that in a hybrid setup. Because like if I don't do it, then there isn't any common platform what setup sort of is available for others.
Is this a biodegradable?
Yeah, that is 100% biodegradable.
So Kiran, when you service the clients, it's mainly up to the prototype and the initial design stage?
We also support them for production, but we are.
Production would be a volume game, right? So are you?
That is correct. So as a company, we work to a stage where right now we are taking up production only in say some specific sector areas. Not that we say yes or we are trying to compete. I don't have a full strong project management team or a full sales team say to be able to start competing at production. What is happening is production doesn't happen in India. So for various different reasons that we also don't have that necessary capacity. For example, we need Vistrons and Foxcons to come in and set up their plants here just to make Apple devices. And these companies are not from India. So what happens there again is, when the league of the product, at a production level sort of changes, when it has got a huge reception from the market, so that contract manufacturing is at a different level. So in contract manufacturing alone, we can have, say, different category of requirements. Say flexible contracts, for which today we have a lot of software SaaS app companies who are trying to sell, saying that you can establish flexible contracts between all sort of your suppliers and vendors and so on and so forth. Don't realize actually saying that there aren't too many suppliers who are actually accepting it. The reason is because they are constrained to say only doing a certain few things, and they can only deliver product quality to a certain extent. So the gap which sort of becomes there needs to be sort of addressed. So for a product to become good, if 2 small Indian suppliers are required or 4 small Indian suppliers are required, there isn't too many people who are trying to bring them together and then deliver the product.
So this would have IP or confidentiality?
Yes, our platform is the IP. So we've been working and also utilizing aspects of AI in making the right templatization, say optimization of identifying where, say, we have availability of work which is sort of available. So in a sense, saying that our suppliers tell us saying that I'm vacant right now, give me orders online. So what happens is that you can plug and push orders concurrently to be able to deliver it faster. So it's like Zomato or Swiggy assigns their pickup boy based on their nearest availability, based on the restaurant you choose to book the order. So in that sense, we streamline that process to make sure that the work gets started automatically and delivery happens at the earliest.
How you are finding the demand in the market now?
So we have continuous demand. So we have plenty of pipeline, because what is happening is, one is fortunately or unfortunately, mechanical engineers who have studied mechanical engineering end up joining a software company. So most manufacturing companies don't have the right set of talented people. So that is actually giving us a lot of push to actually create this space, in India.
Any other questions?
Thank you.
Thank you for the wonderful presentation, sir. I now request Dr. Jyoti to hand over memento to Mr. Kiran from Printalytics. Thank you, ma'am.
Thank you.
It's now time to move on to the next event, which is panel discussion. I now invite our panel members, Dr. Nagaraja D, Dr. Arvind MT, Dr. Sonali Gupta, and Ms. Hema Malini for discussion on the topic School to Startups Igniting Young Minds to Innovate, which happens to be the theme for the National Technology Day 2023. panel discussion will be on the topic, which happens to be the theme of the National Technology Day 2023, which is School to Startups, Igniting Young Minds to Innovate. Thank you.
Good afternoon to everyone. We are into the last of the technical sessions of this today's program, National Technology Day 2023. Now we have for this panel Dr. Arvind, who is the CEO of Ramaya Vedut, which does take care of the entrepreneurship innovation here in Ramaya University and also for the whole GF group. And we also have Malini actually, but she's the past president of Click, and she also has a lot of experience in the what you call startup innovation and related activity. And then we also have Dr. Sonali Gupta, who is the director for Center for Entrepreneurship. Okay. So this topic is very much related to the student community at large actually, because school to startup means that is all education institutions will be a part. Which the question is from where we start the mindset for innovation or entrepreneurship is the only question. Now because of the shortage of time, because we are running behind the schedule, now I request our panelists to just give their insights and their perspectives about the theme, what can be done, etc. for about 5 to 7 minutes, and I pass on to the three panelists. Then after having one cycle of their views, if there are any addendum to that, we'll give the opportunity. Then if there are any few questions, we can take it. With these remarks, again, I appreciate our panelists to have accepted our request to be the panelist for this session. Now, okay, no problem. Madam, you can start.
Yes, let us start. So, good evening, everyone. I think a few minutes ago, it was very interesting to see the presentations by the incubators here. I was especially impressed, and I like that they were all into hardware and manufacturing, because normally most of the ideas that I get to hear these days, I also run mentoring sessions for students from university and outside, are related to software. And I think Ayush mentioned somewhere that he's very proud that all the interns are joining hardware. Coming back to this theme for this day, from school to startup, I think we lay a lot of onus on students all the time that they have to come up with a brilliant blockbuster idea, and then there is this incubator and they must approach it, and then they must get the things done. But as an educator and especially as an entrepreneurship educator, I think I would like to share with the panel and everybody here today that I think we need to do a lot more to enable that. We need to encourage our students to actually start up or actually work on innovative ideas and to build innovations. The reason for that is that I have always felt, when I was a student or when my child is in the school and college, that we train our students, we train our children to have guarantees in life. You work, you study hard, you learn all this, and give your exams and you'll score your marks. And marks are guaranteed if you study hard. And once you get your marks, you'll be promoted to the next class. That's again a guarantee. So you reach your 10th, 11th, 12th like that. And because you have been reading and learning and you have been scoring marks, you'll get an admission in a good college, guaranteed. Again, you get admission in a good college, so you work hard again and you score the marks and you'll get a placement in college in a good company, guaranteed. So one thing which I'm sure my young innovators in this room would agree, in innovation and in entrepreneurship, there are no guarantees. So somewhere we are training our minds, our young minds, to have guarantees and certainties at all times, whereas in entrepreneurship, there is no guarantee, there is no certainty, and you deal with things that come up as they come up, and you change your path, you pivot or you innovate, and you find your way out of it. So I feel when we talk of this idea of school to startup, there is a lot of onus on us who are the educators, who are running these institutions, and we must work together with our students to build that mindset from the beginning and not guarantee them success or guarantee them something which is actually not going to lead to innovation. Because the only thing when innovation happens is when you don't have guarantees. When you're so driven by a problem, when you're so driven by an idea that you want to make it work, you don't know if it will succeed, but then you know that it will make a difference to the world. The world will not be the same without that addition. I asked him why Mvega, why Ola is already there, but the guy thinks he's moving a needle. He doesn't know how the commercialization will go, with due respect to you, but he is making a dent in the universe. If I can use a quote by Steve Jobs, that we all are here to make a dent in the universe. And that's what we do through our innovation and entrepreneurship and technology. And so to all the youngsters here and to my peers, I think we have a lot of onus that our curriculum tells our students that you can develop an entrepreneurial mindset while you're in school and college, that you don't have to have guarantees for everything, and that it's okay to fail because you are the one who will define the failure for yourself. So on that note, I think I would pass the mic to Seema.
Thank you so much. It's indeed a great pleasure to be part of this particular session, and more so when I heard from the incubators. I think there is a tremendous kind of development which is happening in terms of innovation, incubation, entrepreneurship, and the kind of efforts which have been happening from the institute or from the academics is also, I can say it is quite good, and these things were not there when we started. Okay, about 20 years back when we started off our company, I'm just telling you about the industry perspective. MSMEs, the struggle which we undergo through the phase of our journey. 20 years back, we started off as a training center, CAD CAM training center. It was just a passion that we started off with this. I think most of the startups, they have that passion to do something on your own. You want to stand up and you want to demonstrate your capabilities and not work for somebody else. And you have that focus, you have the passion, you have the commitment, you have the dedication, and that is where you're moving forward. After I can say after a journey of about 4 years where we did really well in the areas of training, we were the first training center in private sector in South India, that is CAD CAM training, and nobody else were there. We tried to innovate in our business in whatever we were doing. We started working with the industries to bring in a particular module for practical oriented training. That is, we developed the CAD CAM stuff, we developed the module. We also practically implemented in that particular tool rooms, Indo-Danish tool rooms and Indo-German tool rooms. See, what I suggest to any particular startup is define a USP for your own company or for the product or the service or whatever you are doing. That is where you will be able to bring a lot of value in your project or a company which you are going to start off. So with that particular, see, you have the passion, you have the dedication, focus, commitment. You may also have a lot of funding which is coming up. Earlier those days, we struggled to get a loan of 3.5 lakhs from the bankers, where we had to invest in our software. The times have changed now. So now here we have Startup India, we have Startup Karnataka, Invest Karnataka, and a lot of funds are available. And we also have a lot of channels which you can use to get this particular sources, getting the funding done. It is only that you will have to have a lot of networking with the academics, institutes, and the incubation centers, and also with the government. If in case you have that particular complete network, you will be able to at least get some particular knowledge on how to get the particular sourcing, because that is a basic point where most of the startups are not able to even get to that particular level of developing a particular product or the service which they are going to get into. So this is when we started developing. After 4 years, we started feeling that there is a saturation is coming up in the industry, and we had to get into the engineering services, because I was from the manufacturing background. I was a mechanical engineer. I did my masters in tool engineering. So our passion was into more of manufacturing and not into training. So we started getting into the manufacturing, and we were fortunate enough to have some of the big corporates coming to us, because our USP was good engineering and quality. So develop that particular USP for you. That is what I am saying when you are trying to bring your particular value into whatever product or service you are trying to bring in. So continuing the journey, we went into the industrial automation sector. You can see whatever industry 4.0, we try to integrate mechanical, electrical, pneumatics, hydraulics, complete robotic systems, complete line assemblies is what we started serving to the automotive industry and aerospace industry. And we built our name in the complete India. We were one of the system integrators who could deliver global level automation systems. We started indigenizing a lot of our own projects. We were a project-based company, and we used to serve the automotives of the types of Maruti, then down south Toyota tier 1s, then we also started serving TVS, Yamaha. So you have to build your own space and your name, quality and reliability of your products and sustain in your particular businesses, and then I think all the other things will fall in place. And this is a good journey, as my co-panelist she mentioned. There's no shortcut to success. Okay, there's a lot of hardships which are there. You will have to build a very good team. You need to identify the stakeholders who are very much required in your complete business plan. Put on a proper business plan. Start working towards it. Have your vision and mission clearly defined, and start innovating. When you start, you don't know why you are starting this. We never started to run a business and get into a merger of our business in 2019. Our company got acquired by Wipro Infrastructure. Out of 150 system integrators, they evaluated. They came to us, and we were acquired by Wipro Infra, and we stayed and we handholded this particular entity for 4 years, and we were able to see that success of inorganic growth. For inorganic growth of about more than 100x times within a period of 3 years. So that is a value which we created in the particular enterprises. So create that enterprises value, have a clear business plan, bring in all the stakeholders. It can be infrastructure, it can be resources, it can be your financial system, it can be your mentors. Like one person in the previous presentation he showed, he has got a lot of mentors. I think that is where you will have to leverage all these stakeholders, and I am sure that you are poised for an extremely good growth. Thank you.
Good evening, everyone. Theme is school to startups, right? Okay. So when you talk about school to job, we teach our children, like Shinali said, we teach our children how to do it. There's a process set. You send them to school, pass, get good grades, and then you get to a college, pass, get good grades, and get a job. But when it comes to entrepreneurship, we just jump, directly. You haven't learned cycling, you climb onto a cycle, and most of the times you fall. You don't know swimming, you jump into the water, most of the times you drown. So the number of startups that fail, despite the number of startups that have increased, the percentage has remained roughly the same, right? More than 95%, 90 to 95% at least fail. They fail at different stages. Year one, most of them fail. Some survive for 5 years, suspended animation. Some never grow. Some remain mom and pop shops. So the reason is that as we teach the children how to succeed in getting a job, again, there is no formula that will tell you how to succeed as an entrepreneur. Right? It cannot be taught. Being an entrepreneur is not something you can teach. It's something you have to learn. It's a skill that is non-cognitive. Entrepreneurship is a non-cognitive skill, and it cannot be typically taught in a class. People have to learn by doing, right? Learn by thinking, talking to people, and doing. And unfortunately, we don't do that. Especially if you're getting out of college, I have a brilliant idea. I think, my prof has a brilliant idea. I had an idea. Then we built a nice prototype. So now everybody should want it. Let's set up a company. Doesn't work. Then there are lots of hardships because you realize that it's not going the way you thought it's going, right? Because nobody wanted the product. You're not getting sales. So all that happens. So I think if you want to do schools to startups as a success, one of the things is that you need to catch them young again. Don't catch the engineering students in their final year when their mindset is on placement. Then don't give them a project and say, are you going to start up? Other times they won't come. There won't be continuity. Try to catch them young and probably, do less in the classroom and more on the field. Right? Try to push them out. Look at real life, understand the market, look at the ecosystem, what's happening, who are your competitors, why are they buying the product. That's what they need to understand. So if they understand and they still have the courage to come back and say, I will make a startup and I know what I want to build because these are the people who want it, then that's a good time for them to become entrepreneurs. So entrepreneurs don't happen overnight. They happen by learning a lot, by picking up a lot of skills. And it's also a mindset, right? Entrepreneurship is a kind of a mindset. My co-panelist said, you fail so many times, but every time you learn something and you don't give up. You learn not to give up. You learn resilience, right? You learn, and in entrepreneurship, most of the things are not under your control, but you still make it happen, right? These are things you cannot be taught in the classroom. These are things that are learned by experience, but we have to have a framework to do it. Otherwise, schools to startups will be just another, you cannot build an academic program that will help people to go from schools to startups. Because at least for getting a job is very clear. The company will say, I will interview people with that many marks, at least this cutoff marks in this subject. They're willing to hire you, and then they're willing to invest on you to become productive. But here you don't have such liberties. Emma said, funds are now available. And sometimes I feel that's a curse, right? You don't have clarity, you get money, you get complacency. And you keep spending the money, you don't really know what to build, and you continue in that sense of complacency for a long time. Right? So schools to startups is really a matter of, taking people young, inculcate that mindset of what entrepreneurship is, how to become an entrepreneur, what are the challenges you might face, learn, what kind of problems are required to be solved, who wants to pay for it, how will I make money, and that kind of stuff. I think this stuff is taught less and learned by themselves more. So, thanks.
Okay, I want to just give you now that is how our mindset, our outlook has to change. Now, if you have to become a startup or an entrepreneurship, because now the context is slightly different. At least now when we were the engineering graduates, or at least in our generation, I would say, if you really look at it, what are the inclination for family members to encourage the graduate students to our preference was, if you can get into a government job, there is nothing like that. Whether it's the state government, whether it's the federal government, the central government, if not the government job directly, whether I can get into BEL or ITI or ECIL, etc. That's what but the outlook what we had. Or let us say you become a teacher in a what do you call it, government college. See, that was the outlook now about at least about 20 to 30 years. Now, how many were willing to join the private industry or private organization at that time? I think very, very small. Okay, obviously, if you are not able to go there, you go there. How many were going wantingly or on their own to private organization or private industry about 30, 40 years? In fact, I am surprised that now I am serving in a private organization. I'm telling you. So when I studied, when I was there in IIT, my preference was to get into the government organization. The reason why, see, the difference between the government and the private organization in general, at least at that time. See, we look at what we call as some sort of a certainty. Okay. Once you join, unless you do something terribly bad, correct? Now that is your job is safe, and you don't have to bother, but you can work for the organization. But moment you come to the private organization, in general at that time or even now also, so nothing was guaranteed, nothing can be guaranteed. Each one is accountable. But as a private organization of a private industry, okay, a private entrepreneur, whatever it's called, my accountability is not as direct as when you become a startup or an entrepreneur, because the rise and fall, a surplus or shortfall, I alone. That means if I'm starting now, that is depending upon how I do, I will be accountable. If I don't live up to the expectation due to whatever reasons, correct now. So you just see from government to private and private to startup, each one has a different actual outlook or mindset. So that confidence you should have. Okay, that means even though I am serving as in various capacity, okay, please remember, ultimately when it comes to the revenue or governance, correct now, my accountability is not as direct as if I am working in my own organization, because I have to pay check means I have to sign. If I have to, but here along with me there are many people who will be equally responsible or I should say responsible actually. So the way in which we manage our routine, or the way in which we manage our responsibility, then there is a paradigm shift when you go to government organization, government to private to, I should say, entrepreneurship. Now you really look at it, correct? Now I always have to get two things actually. Whenever you are a student or whether there are two types of entities you have to be very careful always. Because knowledge-based skill and skill-based knowledge. Okay. When you are a part of an academic institution or a school, usually knowledge is associated. It is a must. That's what we always presume. Okay. But what is also required is, what part of that knowledge has been converted or can be leveraged as a skill. That is where the translation of the knowledge into skill determines, whether you are well equipped or whether you are ill equipped to take up a job actually. Okay. Many times what happens, I am not well equipped, I may not be well equipped, but my deficiency is augmented or is taken care by somebody else. So in an organized setup, in a startup or in an entrepreneurship actually, that cannot be filled up actually. If I have a deficiency, it will be exposed directly. If I am having a very strong point, it will be rewarded immediately. So there is a direct connect between the deficiency and my proficiency when it comes to startup. Okay. If I am capable, definitely no, the reward is proportional. But in an organization setup, okay, it is not as direct as one comes actually. So it means to say, in my view, because I am not an entrepreneur, I am not a startup person, but after having learned it, this is the translation, what you possess, the confidence in that translation determines your outlook. That means to say, correct, that is, say, they should understand the difference between, there is a technologist, there is a technician actually, okay. So both does the work which is related to domain, but what is the difference between technologist and a technician? Technologists are supposed to have knowledgeable people, but the knowledge has to have been translated to practical skill. And what is merely expected of a technician? The technician also may know many things as like a technologist, but her or his work task is correct now. His skill set is mainly always at a I should say demonstration. And out of that skill, he or she might have gone at knowledge actually. So this startup requires knowledge and the skill, they should go hand in hand. There cannot be any lag between that actually. Quicker the translation from knowledge to skill, definitely that becomes. And how do you inculcate that actually? As Dr. Arvind says, actually, it cannot be taught, but ultimately, the building of the confidence has to come through something, which you have to experience, not as a startup, not as a thing, taking extracurricular projects which may not directly deal with your credits, etc. So that confidence saying that, correct now, what I know, can I translate into something that I can demonstrate that will show my proficiency. If that attitude of demonstrating my proficiency, which has originated from my knowledge means understanding the grasp, basics actually, that how that the grasp is converted to proficiency, that is a must actually. If you don't have that confidence in your translation from grasp to the proficiency, I don't know however hard you take, then only, even if I have to bank on many people to make up my deficiency. I feel that is very, very important actually. How good you are in your basics and how you can apply that basics to something that is doable. What I want to do, that I can define. But what needs to be done cannot be defined every time by somebody else. I have to define and I have to take care of that. So this is essentially the basic difference between working in a government organization, working in a private organization, and working as a startup or an enterprise. Anusha, I'd like to just say whether my perspective is correct or not. This basically this way, and how you inculcate. Correct? No, okay, lab, mere practical in an academic institution is not. Definitely, it is a necessary condition, but that may not be sufficient condition. But how that practical orientation of the subject has to be taken to the next level is where actually that is all of us in an academic institution we have to concentrate.
Yeah, just to add up to Mr. Professor Kadambi, whatever he said, technology is very important. Okay, you have to adapt to the latest technologies. It can be in terms of engineering, it can be in terms of your own sales and marketing technologies or the strategies which you are going to build up in the particular business. Have a 360-degree view before you really launch your startup. See, unless until you know what are your positives and negatives, have an assessment done yourself. Where is your strength and where are your weaknesses? Try to put all the strengths in a particular bunch, and wherever you have weak points, try to work on those particular weak points. There is always an expert available in the industry now. You can get those particular industry experts and help you to really simulate that particular complete process, integrate all your weaknesses into your strengths, and then you should take off. So that is where when we all say about 90-95% is the failures and only 8 to 10% is the success which we are able to see in the startups. I think that is where we lose the balance, and I am sure that all of us here will help you to go to the next level where we can see in the next coming 5 to 10 years, government is putting a lot of efforts, all the associations, being part of the association, where we have about 350 plus electronic industries which are being part of this particular ecosystem. We are trying to mentor a lot of, I can say, upcoming startups. We have a lot of tie-ups with academic institutions where we do this particular mentoring program. We talk to them. We also tell them how exactly they really have to get the experts advice before they start up. You have a product, you have a service, but still what you will have to do is whether my product is sellable, whether I can create a value, whether we have competitors. Do all the analysis before you really pitch in and you get into that particular water. So keeping this in mind, and if in case you see that you are able to start off and the next 3 years you have a vision, look into that before you complete your third year vision. Every 5 years, a particular has to innovate. You will have to see what is the next level which I have to do. Most of the MSMEs, whatever we are doing is we get into the daily, day-to-day challenges and critical path, and we will not be able to focus on our growth. So most of the startups, they become a micro industry, but they will not be able to get scale into a small or medium scale industry. I think all of us are getting saturated. We reach to the level of about 5 crores. Beyond that, I can say in the whole of PINA, we don't have the capability to really scale up. I think that is where we also have to innovate. We are all available. I think all the expert panels here have got lot of experience in themselves where you can really get back to the industry or the academia and see how you can scale up your businesses.
So Arvind mentioned that the startup success rate is 10%. Some people say it's 5%, 1%. Doesn't matter, whatever statistic you believe in.
That's it.
Yes. I think sometimes I find a challenge. I find it, a statistic that is more disappointing than this is that the percentage of people who even attempt entrepreneurship is far less. So I'm talking, I won't give the names here right now, but some of the premier institutions in this country. So I just took a count with them about, for instance, one of them said they have 17,500 students enrolled, and about 100 of them take an elective called entrepreneurship, and 10 of them attempt, and out of 10 I'm guessing one would have succeeded. So out of 10, if one is succeeding, that sounds really nice actually, but out of 17,500, if only 100 are even thinking of entrepreneurship, I think that bothers me a little more. So that's why, to all those who are sitting here, why do we not even want to attempt entrepreneurship? Do we believe that it takes a certain kind of person, some kind of a superhero to attempt that? Or do we believe that we are not good enough, we don't have an idea? These are the things which have been sorted, debated and discussed in the pedagogy that has been developed over the time. So while I can't claim that entrepreneurship can be taught, there are frameworks and heuristics to actually learn how to develop a more entrepreneurial mindset. And I think as long as you're in college, it's the best time to develop that kind of mindset. It doesn't come from books, but there are activities, there are things, there is a systematic framework to achieve that. And that should be your biggest focus and learning, because a venture will get created when it gets there. You will have an idea sometime in life. There will be a problem that will bug you so much that you want to build a venture of it, or you want to solve it and do a social enterprise. But that mindset, that how do you recognize a problem? How do you take that first step? How is it that you're not among the 17,400, but you are among those hundreds out of those 7,000 of students who is actually willing to take that step? So I would wrap up on this note that I think we all owe it to ourselves, no matter what stage in life, to be a little entrepreneurial in our mindsets. And it's not something to be developed by random videos or something, but there are systematic tools which can help you do that. In fact, at RUAS, we are trying to do that through our Student Entrepreneurship Club and even curriculum from next semester onwards. So yeah, it's a challenge. It's in a way, because a lot of people will say entrepreneurship cannot be taught, but I am betting on it that an entrepreneurial mindset can be inculcated systematically.
Yeah, thanks, Sonali. Yeah, so let's try to end on a more optimistic note, right? Entrepreneurship is a skill. It can be learned. It's not something that can be easily taught in a classroom because it's a non-cognitive skill. It is something that you acquire by practicing. And like she said, there are frameworks that will help you. There are tools, but the tools are only as good as you apply them. Right? Just because there's a tool doesn't mean you're going to succeed. You have to apply it to your context and work over it. So it's a hard fought thing. Yeah, there are frameworks, and the frameworks can be taught definitely in the classroom, but it's a skill that has to be acquired. It's not that tough because the Lean Startup framework basically says entrepreneurs are everywhere. You just don't have to be a Harvard dropout in a garage to start a startup, right? You can be anywhere. So it's a mindset that can be taught and picked up, and it's a skill that is learned by practicing, right? More. So I think anybody can be an entrepreneur, and it's worth a try. These days, we are not in the times where if you didn't get a job tomorrow, your whole family will suffer and everybody will die in hunger. That is not the case anymore. I think people have enough backup to try for 3-4 years. Nothing lost, right? Thank you.
We use that word now. It's entrepreneurship is not structured. I happened to listen to a talk by Professor Jane Reddy of Texas A&M. He was telling why now that people find it research to be much more, I should say, difficult, or that is not that easy. He categorized now 3 things. One is teaching, service, and research. So according to him, teaching and research, they are structured. Okay, means once you become a teacher, or once there is an expected service out of it, then there is a regular timetable, well-defined timetable. Question is, with what efficiency you do, you execute it. Okay, there is structure. But most often, thing is, research is not structured. I agree. I tend to agree with you. Now, if I extend this corollary, we really look at it. See, if research is unstructured, because you have to make time, because that is the least preference when you are competing with the other time, like a time for teaching, time for service. So research becomes last, because why? The amount of time that you initially produce may not be commensurate with the output that you get. Okay? Now, if I go one step next, actually, any innovation is always preceded by research. Okay? If I say research itself is unstructured, but no. Can you think of innovation? Can innovation be structured? No, definitely no. This is a higher magnitude of unstructuredness. Now, out of innovation, we are expecting something more. That is what you call startup or entrepreneurship. You see the level of unstructuredness that is there. Unstructured means it is not lack of I should say framework, etc. Correct? No, there is no, I should say, forced framework. It is up to you to adapt. So I won't say there are no frameworks for research, or I won't say there are no frameworks for innovation. But there are no frameworks which are acceptable to you, because there is nothing like acceptable to you. It is some sort of universe. That is essentially, if you ask me as a teacher, as a student, I would say, correct, that is the practical orientation of whatever we learn or whatever we teach, that has to start from the early part of our school education. So that is essentially, it is not that it's memorizing. Memorization is good, but practical orientation will not give you that, memorization will not give you the practical orientation. If you have that practical orientation, there will be better level of confidence and composure in you. And if that practical exposure is experimented by you in a small project, etc., which are not really given in a textbook, etc., that is what you call experiential learning or self-doing. That essentially, it's almost like, I give you an example actually. Say, it is not possible for every one of you to speak directly to audience about 200, 300. When we first started, we may be knowing the things, but just standing before an audience of 10, 15 people, now there is what you call as a stage fear. Okay, you have to overcome that stage fear to become a speaker actually. Here, essentially, it is not that whether I can become an entrepreneur, not that actually. There is an inherent fear, okay, whether I can take that owner's responsibility of defining my future by venturing into something which I am not sure actually. So how do you develop that confidence? That confidence has to has to be developed. But no, either by the system or you have to imbibe that. But first is you should be very confident of what you want to do. That means without knowledge, there is nothing that we can do. Okay, but knowledge alone is not enough. Knowledge has to be translated to skill, and that skill has to reach a level where it should have a proficiency. Okay, the minimum, there is something called what is required and what is desired, what is possible. Many of the cases now we may meet what is possible, but what is required is slightly higher than what is possible. Okay. When there is a shortfall between what is required and what is possible, we are exposed in our proficiency, in our skill, etc. So that confidence you should have. Whatever I have, or whatever skill or proficiency that I have, is that am I meeting the requirement for that? Whether it is a startup, entrepreneurship, or like that, it doesn't matter. When you ask, and if your question is affirmative, then there is a change in the mindset. But it does not mean that no, if I don't possess it, I cannot develop actually. It requires again practice and courage. So in any one of them, whether you want to become an entrepreneur, whether you want to start up, whether you want to innovator, I think no, even if you lag certain values away from the threshold, actually, if you are interested, definitely those things can be inculcated from the I should say school perspective or institution perspective. What you have to take care of the practical orientation of whatever we teach, right from the high school days or from the middle school days. Actually, that orientation saying that okay, see, grade and grasp are different. Okay, you can get a good grade without grasp, but that grade itself will not make you an independent person. When you think you can become an independent, when you think you can become independent, your grasp and grip. Okay, if that grip of that grasp is firm, you can become an entrepreneur or startup. When you don't have that grasp, obviously the grip will be loose only. So please let us try to have that imbibe that aspect actually. Grades do matter. Grades have to be associated with grasp. If the grasp is there and grade is there, then you can have many advantages. But most of the cases in contemporary, what is happening is we are having grades, but that grade does not reflect the desirable grip for the subject or grasp for the subject. So this deficiency we have to overcome. As a teacher, we have to overcome. As a person who will be teaching the student, we have to overcome. Then that is the only way. Otherwise, we can keep talking, but nothing is going to happen. Because why? That ability to do independent thing is a must for an entrepreneur or a startup, because that requires extra confidence in you to carry out actually. That confidence will only come when you have a confidence. When you have a tremendous confidence, you will be composed. When you are composed, you will have capability. Okay. So these things come with a lot of practice, and without practice or without time to develop those skills, how much sermon I can give, it is not going to help. So that is what I'm going to, whether it is an incremental improvement, whether it is a drastic improvement, it does not matter. But there should be attempt on our part to make our students, ourselves, correct now, becoming more independent, better grip and grasp of the domain, and that grasp and grip have to be shown as a practical oriented to solve the problems of the business. That's what I get. Okay, I think with this, thank all the panelists. Now, if there are any questions from the audience, probably we'll try to take. If there are any questions.
Quite late.
I have a question. So the thing is, like, most of the time what I've seen in the students is they don't know how to start with the startup. Like IIC is there, MHRD is giving funding for the startup, so many things are there, but students are unaware most of the time how to go about, how to start. So one suggestion from my end would be, at the academic level when we are starting, we should have them being open to all such kind of avenues from where they can start. So that is one thing I want to just have a suggestion.
Anush, do you have anything to add? Yes, surely.
So, apart from with you, all peoples, for For example, whatever you people are told is like a blueprint for the startup. But moreover, then everyone should have to have the interest to become an entrepreneur. So if you have that one, it is a very important to reach like a. For example, I have to see some like I have to feed my own students like Ramya students. They go and ask anything about other things like not only technology, any other things regarding politicians, regarding love stories, regarding anything. They're very much interested, but they're not interested in this segment. So that fact we have to focus more on the students. So because we have a knowledge, we have a very good stuff, so that we can make any kind of things. But where to sell that one, they don't know. That one fact we have to reach that one. We need a transformer for that who can make that knowledge into a sellable product. Once that comes, then definitely students will have a motivation and an interest towards that too as entrepreneurs.
That is regarding the rural sector. Now, the important thing is that nowadays in the rural sector, the students are not interested at all, we can say. The thing is, there's lots can be done in the rural sector. So once they pass out from the colleges, and then if they go back to their own place, to the native place, there is a lot of scope. So how we can, as a mentor, we can train them that yes, there's a scope in that. Please go ahead with it. So if you can highlight on this, it will be good.
I think in the rural sector also there is enough of traction which is available right now. If you look at Hubli Dharwad segment, more than what we are able to see as entrepreneurs here in Bangalore, we are able to see there is a traction there because Deshpande Foundation is there. So I think because of this particular lot of industrialists who are there in that particular segment, they have come together and they have been encouraging a lot of startups, and they also have their innovation centers. So I think there is a big role to play from the academics itself to ensure that all the startups have got particular incubation center like what you have in RUAS. I think it's a good platform, and there is a lot of encouragement also in the rural segment. But I am sure that it has to reach to the, I think, tier 3 cities or the villages, which we actually call it as rural. There is very less awareness, but there is one association who is doing extremely good work, not today. From the past 30 years, it is called as Awake. It's a women entrepreneurship group, and they have been going to all the villages and they are trying to promote it. But unfortunately, what's happening is, unless all the stakeholders like the government, the associations, the industries itself, the people who really want to start up, they all come together and create a framework. And also there should be a lot of funds available. See what happens even for the associations, if you ask, they're all non-profit associations. So if the government have got some particular funds wherein a lot of awareness workshops can be taken up and delivered, I think there will be encouragement in the rural segment also, is what I believe. Anything to add?
You got yours.
Any other questions? Okay. If there are no questions, again I thank all the panelists for their time and efforts. Okay. I profusely thank them for their involvement and participation. Okay.
Thank you all for your valuable inputs. I now request Dr. Govindar Kadambi to hand over the mementos to Ms. Hema Malini. Dr. Sonali Gupta. Dr. Arvind MP. I request Dr. Shrikant Dutt to hand over the memento to Karan.
ನನಗೆ ಪ್ರಿವಿಲೇಜ್ ಕೊಡಿ ಸರ್.
Thank you all. As we come to the end of today's event, National Technology Day 2023, I now invite Dr. T. Naranjan Prabhu, Professor and Head of the Department of Chemistry, to deliver the vote of thanks and concluding remarks.
Good afternoon to all. I would like to summarize today's event from morning and what has happened. Just a glimpse some of the highlights from various speakers and different events that occurred from the morning. Today's program, National Technology Day, started with the inauguration by dignitaries, including Chancellor Dr. M.R. Jairam, along with the chief guest Dr. Chandra from TCS, and we had Dr. Pillai with us, and also our Vice Chancellor Professor K.K. Raina, Chief Executive Srinivas Murthy, and Pro Vice Chancellors Dr. Karbanda and Dr. Kadami. The keynote speaker for today's event was Dr. Chandra from TCS. He gave a talk on quantum computing and quantum information, where he emphasized on the possibilities of startups in this newer field of technology. He highlighted the investments in India through National Quantum Mission of Government of India and Quantum Research Park from Government of Karnataka, which are opening new avenues for budding graduates. Some of the technological problems in quantum computing, such as decoherence, gate fidelity, readout error, qubit connectivity to be removed to get the required output. Dr. Chandra also highlighted major of research focus areas in this newer field, where quantum enhanced optimization, machine learning, sampling and stochastic modeling, quantum chemistry in design of molecules are some of the areas which he highlighted in his talk. Later, the guest of honor, Dr. Pillai, is well known as father of BrahMos, and his book was released during the event. During his talk, he emphasized on various aspects, including a country which is strong can only advocate peace. In fact, he was referring to India, where we are becoming a global power. He emphasized on precision agriculture using space technology, and Indian energy sector is growing with the new addition of nuclear reactors, solar energy and wind energy, and also most recently the hydrogen energy sector. In addition, growth of Indian aerospace industry is at the newer height, and he suggested to explore establishing startups in the area of cybersecurity, where government funds are available. So this was followed up with the inauguration of ground control station Ramayasat by the dignitaries, where this ground control station forecasts the weather across India by retrieving information from 5 different satellites. Later, in the presidential remark, Dr. M.R. Jairam, Chancellor RAS and Chairman GEF, recalled the centenary celebrations for founder chairman, Dr. M.S. Ramaya. He told that inauguration of ground control station of Ramayasat is a befitting tribute to Dr. M.S. Ramaya's contributions. Dr. Jairam highlighted the growth of science and technology in the last 2 decades and the need of stepping up the pace of scientific contributions by the scientists. the need of growth of applied sciences in India are going at a very high speed. In this direction, he highlighted the establishment of School of Advanced Studies and later on Ramaya University of Applied Sciences, where more focus was given on applied sciences research. He complemented the innovative developments happening at RUAs across departments. Dr. Jairam highlighted the audience enlightened the audience about the GF initiatives on creating a new unit of strategic studies, Techno Innovation Center, with the residential hostel complexes, and also emphasized the significance of industry institute partnerships and the contribution of faculty within the university. He also announced that in few years we will be coming up with a new PG program on quantum computing. After this, Professor Govinda Academy gave a vote of thanks where he thanked all the dignitaries on the dais. Two technical talks were given by distinguished speakers. One among them was Dr. Ashish Kushu, where he emphasized on artificial intelligence and technology that will combinedly helping the industry to grow. Innovation is a culture, you need to develop it. So read, write, and explore more in this direction. AI and CS technology, it can exchange the job, but it won't replace the jobs. He also highlighted that don't do jack of all, master of none things. Be the master of one of the focused areas to excel in that particular area. In the second session of Dr. Shivatanu Pillai, he highlighted the need of energy, the growth of energy sector in India, and how sustainable energy is very important for not only Indians across the globe. Sustainable energy is very, very important. So this sustainable energy is related to good life, and also related to the environment, our health, GDP growth as well. So we need to reduce the pollution and reduce our consumerism to reduce the pollution in turn. So in the panel discussion, where the title was School to Startups, Igniting Young Minds to Innovate, was this title. Dr. Sonali Gupta, she suggested, various forms of startups that are possible. One need to define USP for a product and service. And Dr. Hema Malini, it is, she gave it and highlighted the point of it is okay to fail. It is okay to fail. We are the ones to define our failures. That means everyone undergoes failures. So it's fine if we fail. Later on, we can succeed. Dr. Govind Academy moderated the panel session and in his remark advocated the youngsters that devil is in the details. You just need to start and get into the problem, solve and win over it. Entrepreneurship, being an entrepreneur, you need to be calm and composed, which is very important aspect, and this comes with practice. He also told that knowledge alone is not sufficient, you need to transfer it into the skill. So that is, we need to practice when you become an entrepreneur. So with this, I have completed summarizing the event in very short duration. I hope I have covered most of the points which have been covered. So I take this opportunity to propose the vote of thanks to the speakers who gave very knowledgeable speech in the morning sessions and also in the afternoon sessions. I thank the whole organizing team with the able leadership of Professor Govinda Academy. Because he is the one who had mentored the whole team, day to day, since from almost more than 1.5 months, they have prepared a lot in conducting this event. A lot of faculty members have been involved into this team in organizing this. We profusely thank all this team who have worked tirelessly in making this event successful. I also thank the supporting staff members who have contributed to the success of this event. I thank the non-teaching staff in arranging all this event. Also, I thank the chairman, GF, CEG, GF, and Vice Chancellor, Professor K.K. Raina, Registrar K. Venkatesh, all deans and HODs, directors of various divisions. Most importantly, the students, media personnel. I thank one and all who are here, who are at present not here. I thank profusely for making this event grand success. Thank you one and all.
Okay. Thank you, Dr. Prabhu. You have summarized very well. Yesterday, I was talking to our team members, coordinating team members. At the end of the valedictory or in the valedictory, I felt all these accomplishments, but all it is called as accomplishment. And these things with many things we have to undergo would not have been possible. But for as I used in my vote of thanks, that is, I should say, responsibility sharing, shoulders, helping hand, and I should say lunging forward and bending backward backbones. And more importantly, the tremendous and the unwavering the support and the initiatives, that appreciation. Now I request the following members. Of course, many have contributed. I'm not, but at least who have contributed consistently as a part of these things. So I would request them to come, and it's my great pleasure to really thank them on behalf of our university and also on my personal behalf, just to convey the heartfelt appreciation and I should say grateful thanks to them. Okay, so I request Jayhar to come.
Dr. Siva Prakasu.
Thank you, sir.
Ms. Pranupa.
Thank you.
Ms. Anusha. Mr. Praveen.
Thank you, Praveen.
Dr. Niranjan Prabhu. Mr. Arun V. Dr. Jyoti A.P. Ms. Rupa Patil.
Thank you.
Mr. Lohit. Mr. Nagraj N. Mr. Nagraj B.N. Mr. Deepak. Dr. Varun.
Thank you, Varun.
And myself. Sahana B. Shankar. Ms. Nandana Narayana.
Thank you. So we have also other names, so we'll, I personally give them.
Yeah.
Certain,
Tell the names.
There are many more members who have contributed for the National Technology Day. They are not present here. Then Mr. Satyanarayana, Mr. Gautam from FAD, Mr. Dr. Vishnuvardhan, Mr. Lokesh AC, Ms. Rohini Keshava, and Dr. Rinki Sharma from CSC department. Thank you all. IT is organized outside the auditorium in the quadrangle. I kindly request all of you to help yourselves with tea and snacks. Thank you. Okay, please wait. I request all of you to please rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि जनगण मन अधिनायक
Sir, it's playing in the background. 1 minute, sir. We'll sing now. Forget about it.
Yeah, we don't get too much opportunity to sing. To sing the national anthem.
True. Just now we had one round with our students, school students.